Hello, everyone. Welcome back to Ask a Scientist Gaming, where we combine mediocre gameplay with expert science. I'm Ken Hansen, Associate Professor in the Department of Chemistry and Biochemistry at Florida State University. I'm a photochemist / photophysicist. I shine light on molecules and materials, and I want to know what happens to that light energy, whether it's moving electrons around, protons, energy, making and breaking bonds, and hopefully doing something useful with that knowledge, like solar energy conversion, photocatalysis, what might come from that energy. But more importantly, joining me today is Chad Weisbrod. Chad, if you wouldn't mind introducing yourself.
Yeah, I'm a research faculty at the National High Magnetic Field Laboratory. I've been working there for very nearly 10 years. I am currently the director of instrumentation for the ion cyclotron resonance division. So I spend a lot of my time building, upgrading, and fixing the instruments that make the measurements for our world-renowned user program. So that's kind of my introduction. I'm also a husband and a father to three beautiful young girls.
I think at least one of them is in chat right now. So welcome to the stream, everyone.
Yeah.
All right, Chad, equally important, what game are we starting with?
We're going to be starting with a game called Kirby's Dream Course. And
Dream Course.
This is a bit of an homage to a good friend of mine that introduced me to this game. It's a fun game, and it's basically a game where your physics are tested, and you can. It's almost like a golf game with Kirby in a sense.
Yeah, I had fun playing this. It's like billiards combined with golf, with geometry, with
Yeah.
And Kirby's a classic character, so that's awesome.
Yeah, conservation of momentum. All these principles are part of the deal, so it's good.
Freeman Thomas, welcome to the stream. First time chat. Thank you for joining us. Presumably this is one of yours friends and colleagues that got emailed about the stream tonight. You guys can let me know if the volume's too loud or too quiet. We're happy to adjust.
My eldest daughter told me that I needed to not embarrass myself, so I'm trying my best not to do that right now, but I'm sure that at some point in the night I will.
No worries. Yeah, we'll give you some time to settle into the gameplay, because those of you that haven't done this before or haven't been to Ask a Scientist Gaming, it is a challenge to talk and play video games at the same time.
It is for me.
And yeah. Maybe.
Oh. I was going for the hole in one there, but I fell short.
Yeah, and I'll also note that Chad braved the weather here in Tallahassee. With those of you not familiar, we got like 2 inches of snow or something over the last day. So school was canceled, both grade school and FSU, both yesterday and yesterday afternoon, today, and tomorrow. So
That's true. And my kids were looking at the weather forecast all the way up until last week. And my youngest was telling me, she was predicting that we would have off. She would have off of school and that we would not be going to work, and she was right. So.
Wow! Shout out to her.
So this game is it's pretty. The first level is obviously like an introductory thing, and it gets progressively more difficult from here. So let's see what I can do.
Contra, welcome back. Thank you for the tier 1 subscription. We really appreciate it. You help our drinking habit and our gaming. So cheers to you, Contra. Thank you for joining us. If you have questions for Chad, put them in chat. We're going to be happy to answer them. We'll get into it a little bit. We're going to let Chad settle into talking and playing video games at the same time. He was a little nervous about that. Apparently you are a gamer. You regularly game.
I do regularly game. That's true. I think it's a great way to relax. I also think that I wanted to thank Ken for having me on, because I think this is a great way to do scientific outreach. It's certainly my pleasure to be here. But, gaming is something that I'm used to doing in a very solitary way. Like I just sit there and sort of meditate on my gaming. So I don't normally converse and try to actively engage in conversation. So
I'm going to turn the sound down a little bit on this guy.
Sure.
It's a little loud. All right, there we go. And Chad, thank you for, especially on short-term notice, because my guest had to cancel tonight because they had a seminar speaker, which ironically got canceled. But Chad, I think you said yes like a week and a half ago. So we hammered out a whole lot, from bios to predictions to whatnot. So thank you for joining me.
Yeah, no problem. It wasn't too much of a onerous process.
I don't know, the predictions, it's hard to brainstorm on the spot. Like a few.
Well, we'll see how they go.
That's fair.
Yeah, so 4 on that course was that was on that whole, that was not necessarily what I was looking for, but you know, you do what you can.
Schmo Night, welcome back. King Willie. It's all the regulars are back early. Yeah, we didn't have school today, so I'm excited to be talking science again because I've been at home all day. I love my kids, but also there's only so many Legos I can do before I go a little nuts. So I'm glad you guys could join us. We're looking forward to the conversation. So this is just golf rules, right? You're just, you have to get through the object in a hole.
There are golf rules. However, there are like power-ups. So like in the later stages, you earn power-ups and you have to use them you have to destroy all the enemies, and then the final enemy turns into the hole that you have to make it into. So that's kind of the basics of it.
Oh. So this is, you have to make par, is that the...
Yes, you have to make par, and I'm woefully trying to do that at the moment, but I'm struggling.
Well, we'll add to your struggles by starting with our opening question. We ask every single guest because a lot of people think those of us that are scientists always knew exactly what we wanted to do with our lives, and that's rarely the case. So 6-year-old Chad was probably not anticipating working at the Mag Lab doing FTICR. There was a winding road that brought you to where you are. What were the major, steps along the way, milestones you remember, forks in the road, and particular events that led you down the path that got you to where you are now?
That's a great question. I ended up... I was always somebody who gravitated toward the sciences, and so I ended up, doing my undergraduate in chemistry. Mm-hmm. And I had one of the things that sticks with me in life is that I've had this wonderful preponderance of mentors that have always sort of pointed me in the right direction. So I ended up with an undergraduate research advisor who urged me to go to graduate school. I didn't at the time realize that you could go to graduate school and get paid to go to graduate school and do science. And so for me, that was a pivotal moment. It really was. And so her name was Robin Tankey. She was...
Shout out.
Yeah, shout out to Robin. She was... we did research on germanium triphenylphosphine oxides that were potentially useful in like... as MRI contrast reagents. So that was like the thing that she was having me do, is synthesize these things. But I don't do any synthesis anymore. But at the time it was either go to graduate school, honestly, or become a synthetic chemist at what is it? Oh, I'm drawing a blank. The chemical Sigma Aldrich, because it's actually in Sheboygan, Wisconsin. They have the Sigma Aldrich plant, and so you could make good money as a synthetic chemist there with just an undergraduate degree. So that was my other option. Mm-hmm. I'm glad I didn't.
But as soon as you learned you got paid for grad school,
yeah, I was like, let's go for it,
Yeah.
So, yeah.
All right. So, but choosing chemistry, I mean, you knew that going into college?
I did not know that going into college. I just I was drawn to chemistry just because of the way that you can learn more about the natural environment and understand how everything works, but it's on its most basic levels, so for me that was a huge draw.
Yeah, no, I agree. Build the world from the atoms up. All right, so you graduated with your PhD, and then what?
I actually ended up becoming a visiting scholar scientist at the Magnet Lab to start with. So that was for me, that was I guess skipping over, that sort of glosses over a lot of, for some folks getting their PhD can be a long road. Mm-hmm. And I think one of the things that happened to me was my PhD advisor decided to jump to a new institution during the middle of my education, which, I decided to move with him, which was a big decision, but inevitably it was a good one.
Mm-hmm. So that added some time on you then?
It did. I ended up getting a master's at Washington State University, and then I moved on to University of Washington and got my PhD there. Mm-hmm. So
makes sense. And then visiting scientist at the Mag Lab, and eventually research faculty.
Yeah, but I spent some time in industry. working for Thermo Fisher as a senior R&D scientist. So that was another fork in the road. So I moved from Tallahassee to the West Coast, and then stayed there for a few years as a senior R&D scientist working on mass spec technology, and then came back here. Yeah, this part of the level is a real struggle for me.
No worries. All right, we'll open with an easy one though.
Okay.
Drosso Killer. Does the mag lab control the weather? Yes or no?
Oh, wow. Yeah.
It's a good one.
I feel like yeah. As far as I'm aware, the mag lab is able to steer hurricanes, but I don't think it can steer snowstorms.
Oh man, you got that quote directly from a mag lab staff member. Yeah. Wow, that's fun. Rosso, thank you for the question. This is a fun one that comes up regularly, not necessarily on this stream, but with general audience in Tallahassee, because it is one of our. If you guys have been on the Tallahassee subreddit, there's always a claim about the magnet lab.
It's a local ism.
Yeah.
Yeah.
It's but I love it too, because it's like hurricanes miss us a lot. Like
they do.
Urge west, they go east, they don't come right through us, even though they're directed.
No, but truth be told, the magnetic fields are certainly not strong enough to steer a hurricane. But the locals love saying it, so.
Yeah. I think the quote I like to give is, I mean, if you're 10 feet outside of the magnet lab, the field of any of those magnets is less than a refrigerator magnet. Like, it's an exponential fall off. You just do not get high fields. With that said, if you go inside, there's some high fields.
There are. So the unshielded magnets are the ones you have to watch out for. So, I work on all supercon magnets and those superconducting magnets, and those magnets, all of ours are either actively or passively shielded, which means that we have magnets that oppose the main magnet, and that causes the field to drop off precipitously. This allows me to work on them with tools and stuff like that without, having problems. I do have a watch on that let's see if I can. That watch, often it will slow down to a stop when I'm working on the magnet. So it can cause me to be late at times where I didn't realize.
Is that battery powered?
Yeah, well, it's just a mechanical, like, Swiss watch, a nice watch that I received from my wife as a wedding gift, but it because it's just a battery powered mechanical watch, it doesn't function in a magnetic field.
That's intense. I was going to ask if you.
But it starts once you get outside the critical field, it starts to function again. So you just lose that time. It's lost. So, it's gone.
But it was the science you did along the way.
That's right. That's right.
Have you had a credit card wiped or an ID or anything like that?
I have not encountered that type of problem. I've had other issues with magnets that may or may not come up in the discussion as we're talking, but I think there's a question on your list that you have that's like, what's your biggest I don't know, like, what's the biggest mistake you've ever made?
Or biggest accident? Yeah.
But yeah, anyway. I'm not going to talk about that.
King Willie. So the watch slows down near the magnets. So the mag lab is even stronger than previously known. It can control time.
That's right. That's right.
Absolutely. Bend space and time with a sufficiently large magnet. Praise be to the magnet.
That's right.
Contra. Always keep a watch that breaks intermittently. That gives you some attendance wiggle room.
Yeah.
Do you have people showing up late for meetings?
Well, it can work as a functional excuse. That's for sure.
I like it. And so you're on the 21 Tesla. That's one of the biggest magnets, right?
Well, so that's like when I joined the Magnet Lab, I was brought onto the team to help with that build. So instrument that I built as a graduate student sort of served as the precursor to that, and I've just recently completed upgrading it again. So 10 years later, we've been working on an upgrade to it to try to keep it current, keep it up to date, keep it at the forefront of analytical technology. And so, but yeah, that's,
All right, so for the general audience that doesn't know, I mean, you do two things, right? Mass spec is a fairly standard technique. A lot of people do at most chemistry facilities. We have 4 different mass specs over in the chemistry user facilities, but you do ICR mass spec. So let's start with a primer of just general audience. Explain what mass spec is.
So mass spec is just essentially weighing molecules. It's determining the mass of molecules. So we don't measure molecules directly. We're going to measure ions, and that means we can only measure charged particles. Since we use magnetic fields and electric fields to steer the ions, we're going to need to ionize them first. So we need an ion source. We need a way to separate the ions, and we need a detector, and we need a vacuum chamber. Those are the critical components. And it's kind of weird, but like you can build, like, if you know these fundamental facts, you can build a cheap mass spectrometer for, not very much money. I mean, it's pretty amazing. The ones that we build we're focused on building the highest resolution in the world. So we maintain mass spectrometers capable of the highest resolution, highest mass measurement accuracy. So we separate molecules that are, typically they can be less than a quarter of a mass of an electron apart in M over Z. So this is something that's our claim to fame, and to do that requires a lot of electronics, a lot of programming, and a fair bit of cryogenic fluids to keep the magnets cold.
So is mass spec easier to explain back in the day when everyone had a CRT TV, which effectively operates by the same principle?
Yeah, that's true. That's true. I mean, our mass specs are separating. Our principal mode of separating the ions is via magnetic field, so that when an ion enters a magnetic field, it's going to experience what we call a magnetic field force or a Lorentz force. And that force bends or curves the path of the ion, so it ends up creating this circular path. And when it enters the magnetic field, we trap it in between 2 electrodes, and the ion will oscillate and essentially orbit like planets around the sun. And as it's orbiting, we record that orbital motion. It's the current that it generates. We record that current, and we perform some math on that signal and get the M over Z back out. But the basics of it are that really the ion's mass is only proportional to the magnetic field. So it's pretty simple in its primary form, but you can drill down and get more and more complex from there.
Yeah, it's such a cool technique. I mean, in terms of electrostatics, it's pretty fundamentally simple, right? Like
it is
negative thing moving, and if you add a positive thing here, it'll go towards it, or vice versa. And how heavy it is changes how much it moves.
That's right.
Yeah.
Yeah. So when we like to think of ICR as listening to ions, because we're listening to their orbital frequency. So the frequency that they generate is outside the auditory range, but you could downsample it. For the magnetic field strengths we're using it, the ions are at maybe 2 megahertz down to, in the kilohertz range for some large M over Z ions. We look at really small stuff like small molecules all the way up to intact proteins up to 80 kilodaltons. So maybe even a little bit bigger than that, but.
So did you start over, or you got to?
I did. Is that a faux pas in this thing where I'm not supposed to start over? I
have no rules.
I'm struggling to multitask. Like either I'm engaged in the conversation or I'm engaged in the gaming. And
you took a geometrically intensive game.
Yeah, I did. Well, the cool thing is, so you can think of how an ion moves through a mass spec as you can think of its potential energy surface. It always rolls downhill in potential energy, and so this game is, you could envision that at Kirby as an ion moving through a mass spec where we've defined these fields, and essentially this is Kirby moving through the mass spec.
Yeah, I like potential energy wells.
Yeah.
Is it coming back though? You're feeling this?
I hope so. Otherwise, I mean, I feel like my eldest daughter has already proven that I'm totally willing to embarrass myself in front of a live audience.
Has she played this game?
She has not. My eldest daughter will not play classic games as much as I'd like. Sometimes I get her to play Tetris with me, but
Yeah.
that's a tall order.
I mean, for me, it's not even the nostalgia. It's just like kids these days don't appreciate how hard games were back in the day. And you didn't get codes, you didn't get YouTube videos to help you. You just fought on your own when we were kids, and there was that was brutal.
It was brutal. I don't think the kids realize how good they got it these days.
No easy setting.
I mean, we were just talking about how can you have a computer that has like every game ever made on it and be able to select it's almost like decision paralysis in some ways, you know?
So everything at your fingertips.
Yeah.
Yeah. But I'm into the classics clearly, so.
Oh yeah, I can tell that from your setup here.
Yeah. Anyone not on Discord, I added a shelf. This was actually Thanksgiving break. We added the shelves up here for displaying the games. So I should take a photo of that at some point and put it up.
You definitely should. That's cool.
The Nintendo display and then all the retro games displays. But yeah, if you guys have questions, Chris is happy to answer them. He's talking about mass spec, proteomics analysis of complex mixtures using mass spec, really high resolution mass spec. Yeah, it's pretty amazing. Had to bike to the store to read Nintendo Power and try to memorize the moves.
Yeah,
that sounds right.
Or what?
Unless you wanted to pay $1 a minute to call the Nintendo helpline, and they'd yeah. Sorry, go ahead.
I was just gonna say, or like the cheat codes that are burned into our brains, like Contra, or you know.
Oh, do you still remember it?
Up, down, left, right, BA, select start if you're going for two-player.
Yeah. Oh, you got it. Nice. Contra knows what I'm talking about. The hotline, where it's just a bunch of dudes sitting around, like playing video games, answering questions.
Yeah.
I called them once over Metroid. Yeah, unless you got the Nintendo Power magazine. That is definitely
Oh,
true.
yeah, that's right. They had the hotline. I completely forgot about the hotline.
King Willie. It was once described that nano-electrospray ionization is like painting a car. Can you elaborate?
Yeah, so I mean that's probably true. Like you've got this when you create a nano-electrospray tip. Typically, it's done through either etching glass, like polyimide coated glass, or you can flame pull or laser pull a tip, and the tip necks down so that the orifice has a nanometer sized opening. And then when you're spraying from it, you generate this thing called a Taylor cone. And the Taylor cone, you've got on one side of it, you've got a large potential field, and the acid or base you have in your solution, it's a pull toward that across that field, and you end up generating micro droplets which desolvate and get smaller and smaller until you reach what's called the Rayleigh limit, and these charged ions eject from the droplet that are fully desolvated. So you end up with droplets that desolvate as they get closer to the entry to the mass spec, and they eventually become individual ions, multiply charged ions. They usually have more than one charge associated with them, which causes a fair bit of issues with the analysis, meaning that you have each analyte doesn't just have one peak now. It has a peak for every charge state, which is problematic in some ways.
Yeah.
Also fortuitous in some ways. So, yeah.
To give you context, for those of you guys not familiar with mass spec, basically you take something, add electrons to it, or take electrons away, so you add a plus or a minus charge.
Or add protons.
So you can, again, plus charge or minus charge. Well, not minus charge in that case, but you can put that through a field and it'll bend in the field, but you can put more than one. What's the most you've reduced something or oxidized something?
Well, so I there's one of my mentors always talked about this idea called stupid ion tricks. And so the idea is to when you charge something, you can do reactions in the gas phase. So you can use ion traps and treat them like a reaction vessel, just like you would a glass reaction vessel in chemistry. So you can add reagent ions of an opposite charge and strip charge away. You can break bonds this way. It's actually a pretty exquisite way to manipulate molecules in the gas phase. So, but the highest charge thing I've ever observed, I would say, in the 80s, 80 plus charges.
Wow, that's like protein charges.
Yeah. So intact
Something
proteins.
huge.
Yeah.
Is that proton or that's electron ionization?
I typically, most of proteomics is done in positive ion mode. So most of the time you're spraying from just an acidic solution, typically acetic acid or vinegar, sometimes formic acid. But yeah, so that's your charge carrier is usually a proton.
Makes sense. Cuddle Puppy, welcome back. Ken's got to grow facial hair to make him seem anti-establishment in 2025. That is my goal, Cuddle Puppy. I typically am clean shaven on stream, but between every stream, I just let it grow out, especially when I'm not teaching. So, yeah.
Okay.
I'm going shaggy just for you, Cuddle Puppy.
Nice.
But I'm also anti-establishment, let's be clear.
Beard, is this the beard or no beard discussion or what?
I don't know. Apparently the facial hair makes me anti-establishment this year.
I feel like just being a scientist, you're anti-establishment now.
Oh man, it's
I'm sorry.
no, I mean it's true. We are not doing evidence-based practices, that's for sure. At least in a lot of our decision making. Wow, that one sent.
Yeah, I finally I had a brain fart. I forgot that you can change your shot. You can do like a chip shot. You can do a putt.
Oh, interesting. Like you're changing.
That's why I was struggling before. Is
good to know.
If my buddy Mike is on this live stream, he's cringing right now at how terribly I'm doing at this game because normally I'm actually somewhat competitive, but
he's somebody you used to play with.
Yeah.
How long has it been since you played this?
It's got to have been. It's been 2 or 3 years at least. Yeah.
Reality has a well-known liberal bias. Stephen Colbert, you are right, Cuddle Puppy. You're right to quote Stephen Colbert.
Yeah.
Contra, I got into alternate evidence recently, but then I turned the TV off. Oh, man. I can't even watch anymore. Even the internet is just... I miss the old internet.
The old internet? Yeah.
Like early internet, like stupid videos, and you could believe them. And
when it was footloose and fancy free.
Exactly. Like just, the E-bombs world and all the early Reddit was spectacular. Now it's, I don't know.
It's too edgy, like.
Man, my biggest concern is just the stuff.
I will share one of my I don't know if this is going to incriminate me forever or what, but
we'll find out.
Like one of my most proud gaming moments was when I was like 8 years old. I figured out how to pirate Doom off the internet, like I pirated Doom and then unrarred it on my computer and played Doom at 8 years old. My parents didn't know about it.
It's like LimeWire or something.
Yeah. Oh no, this was before LimeWire. I mean, this is like circa, I don't know, 1990. This is
all right. Now you can play Doom on a calculator. That's awesome, though.
That was one of my proudest gaming moments.
Man. Newsgroup era? Yeah.
Yeah, that's the kind of thing. I think it was IRC is where I got it from. IRC is where I got it from. I don't even know if they do IRC anymore, but...
Oh, man. I do not know. Oh, you got this.
I hope so. I think it's unfair. You can't see the angle at that point in time, there's not enough, they don't have a draw distance for the angle of the shot. Oh man, that was too hard. No, I got it. Yay.
Oh, Contra. Did you see where they played Doom with gut bacteria? No, I don't even.
I did not see that.
Series of words put in a sentence that I'm genuinely curious about. Gut bacteria. I'm curious how you program. Here's a video of Doom running on gut bacteria. Popular science.
Is it okay if I steal away from the game to see this video? Oh, wow.
That's like they did a matrix pixel by pixel.
That's
What
awesome.
the hell?
So
So they're not playing Doom. They're executing Doom visuals.
yeah, but that's still pretty cool. Yeah. That's very cool. I like it.
Oh my god. All right, here's a news story on it. If anyone's curious, I did not know that was a thing. I completely missed that, but I'm glad I know now. It took an hour or more to resolve each frame. I'm impressed they got it all to even look moderately like Doom. That is pretty spectacular.
That's I feel like that's already more, that's you got to put that on your CV right there.
It's in your portfolio.
Yeah.
Scientists spend so much time asking if they could. They never stopped.
As if they should.
They had to do it. Had to do Doom on bacteria. That is amazing. Oh, thank you, Contra. I'm glad I learned about that. Today I learned.
So is Contra one of your regulars? Is that the...
Or it's Doom, yeah, sorry. I just said Contra. But yeah, Contra is a classic.
Oh,
It gets played a lot. Oh, yeah. Contra viewer?
Yeah.
Contra's on here regularly. King Willie, Cuddle Puppy are regulars. Yeah, what's crazy is out of any given like cross-section of people viewing, only like 10% actually comment. But you get to know those 10% pretty well, so... We appreciate them as regulars and to vocalizing questions and asking them and conversing.
That's pretty normal. Like in a meeting, that's about how it is too, right?
And in the classroom too. Like
yeah,
250 students, like 5 of them will talk regularly.
Right.
It's probably for the best, especially in meetings. Too many people talking, they take forever. But yeah, let's go back to that question. We kind of dove into it, or you wanted to a little bit.
But I got sidetracked.
No. Let's do biggest mistake and most expensivest mistake you've seen in your time in lab.
Well, the biggest mistake I've ever made is easy. Well, I don't know if it's easy, but when I was a graduate student, I ended up completely breaking a very expensive instrument, an ICR instrument, the same type of instrument that I've spent my entire career building in my PhD advisor's lab in my second year.
Oh.
Yeah. And it was an accident with high magnetic field. So I was helping another graduate student, and I helped her defeat an interlock, which is ill-advised. First of all, don't ever do this. They were doing IR-MPD, so this IR, the infrared multiphoton dissociation. So not only do we trap ions, we also like to blast them and fragment them apart. So we blast them with light, we smash them into neutrals, we beat up ions and break them into their pieces so that we can figure out what they're made of. But this laser wasn't working, and it turned out that the interlock was messed up. Like this little thing that allows the laser to turn on wasn't turning on. So I took a box of drill bits, and I was like, oh, I'll just set this on top of the interlock switch. And it stayed there for about a fraction of a second and then got sucked into the magnetic field. It pushed the instrument all the way out of the magnet. It was such an energetic process that this box of machinist drill bits I'll just show it's about that big. Like it's a typical machinist drill bit set. And the story is actually pretty good because it pushed the instrument out of the field. The whole cart, this is a big cart and it's probably like over 1,000 pounds. And this little box pushed it out of the field. But then, so all these drill bits are stuck in the center of the field. I had to go tell my advisor, first of all, hey, I think I made a big mistake.
I think I made a big mistake.
Yeah. No, this is great because actually it's a pivotal moment because my PhD advisor was like, you know what, Chad? He's like, you're a guy who's in the lab all the time doing work. He's like, I'm okay with this because if you were at home just sitting around not doing anything, you'd have never made this mistake. I'm like, whoa, that's pretty big of you. And it was like 2 months before our big conference that we had to go to, and we were struggling to get data.
And then you wrecked everyone's data acquisition.
So what did? We spent the rest of the evening pulling drill bits out of the magnetic field one at a time.
Jesus.
and so slowly but surely, because every time you're exerting a force on the magnet, you're exerting a force on the superconducting coil, so you could damage the equipment. But I pulled these drill bits out one at a time, and then at the end there was still the box. It was too big to get it out.
It was a metal box.
Yeah, and my advisor, I had the box in my arm, I was pulling on it, and my advisor was pulling on my elbow, trying to get so we got two people like pulling as hard as we can on this thing. And it was a 7 Tesla magnet. We ended up breaking it, bending it and breaking it into tiny pieces. It was a sheet metal box, and we eventually got it out. And then we reassembled all this metal, and there was one drill bit that was missing. Still, and we couldn't, it wasn't in the bore of the magnet, wasn't in the magnet. And come to find out, it had gone into the mass spec and smashed like a critical component of the mass spec and knocked a few components off. So I had to do some research and figure out how to fix that. I fixed it for my graduate student colleagues so they could collect their data. So it was a full circle learning experience for me.
Holy crap.
So I had to knuckle up and get it done.
My favorite part about that story is defeating the interlock wasn't the problem. It's what you used to defeat the interlock.
That's correct. Yeah. And it turns out the sheet metal tab that was defeating the interlock was simply bent, and it wasn't all the way, orthogonal to the surface. So if I had just simply bent that tab down,
that would have done it.
That would have done just fine.
You would have saved yourself. How much did that cost, you think?
You know what? It was
time and money.
Oh, well, it didn't cost that much. So, because all I needed to buy were a couple surface mount components for the preamplifier that amplifies the signal for the mass spec, and solder those on, and then we were good to go.
That's not bad.
Yeah.
So not too much. Didn't take too much time, except for the rebuilding part.
Except for the rebuilding. That story required me to put down my controller. That was a put down controller story.
But you got a Carl Sagan emote with that one because you learned something.
Yeah.
Experience.
Yeah.
Oh man. So, I mean, you supervise students, you supervise visitors. What's the biggest mistake they've done under your supervision, and was the conversation the same?
Oh, you know what? I haven't had that big of a mistake. No one's made that big of a mistake under my supervision, thankfully.
Well, they're not modifying the instrument, presumably.
No,
right?
but I can't think of one off the top of my head. I have seen, there was a graduate student mopping in NMR with a mop bucket, and they didn't realize, they thought it was all plastic, but the squeegee on the mop is just high carbon steel.
Yeah.
And that thing went straight onto their magnet, and that was kind of a big deal. But so that was just graduate student help. Or not graduate student, undergraduate help, I should say. They were
just trying to clean up the room.
Yeah.
That's brutal. All right, we're 40 minutes in. Do you want to keep playing this? Do you want to change games? How are you feeling?
Let's change games.
What do you have some experience talking and gaming? What do you want to do next?
I'll try my best at Mega Man. We'll see how we can. Mega Man X.
So we're going to do some Mega Man X.
Yeah.
All right, so sticking with the Super Nintendo system, 1993, jumping a little bit back in time.
Yeah.
It's only been 30 years. It's fine.
It's good stuff. I mean, Dr. Wily and Dr. Light.
Classic. So volume's too loud, guys, let me know and I'll be happy to change it. We should do one of the predictions. We got, what do you want to do? Chad, which prediction do you want to start with?
Let's try the distance ions travel during a measurement. Let's see what you guys think.
So did you have to calculate this one, or you knew this one off the top of your head?
I sort of knew it off the top of my head, but I did double check the calculation. Yeah.
All right, ladies and gentlemen.
It depends on the M over Z of the ion, of course. So that's the thing.
And so one of the disclaimers things here, this is on an ICR, right? So this is like
this is on an ICR, but we're talking. Remember, if my crash course in ICR was somewhat intelligible, you're thinking about ions that are orbiting like planets around the sun. This ion's going to orbit for the entire measurement duration. So it's just orbiting in a circle. if we unraveled its path that it traveled, how far would it travel? And so would it be from Tallahassee to, would it be less than the distance of Tallahassee to Atlanta, or it would be greater than the distance of Tallahassee to Atlanta?
All right, so the question is up. You guys have 2 minutes. If you guys aren't familiar with the predictions on Twitch, basically you can have your standard internet units that you get for following us or just watching the channel. You can bet those standard internet units and use them for things like requesting take a drink or a factoid or whatever it might be. But in this case, we're going to ask you guys the questions rather than predict things that happen in games. Instead, Chad has written a bunch of science questions. We're going to post those questions at the top of your chat. You see the predict button. Click predict, and you can bet a certain amount of money on a question, whether you're confident in either of the answers that are presented. And so for this question, for an ICR, FTICR mass spec measurement, the distance an ion travels, so you take a species, you ionize it, and you put it through a cyclotron, and you have it circle a whole bunch, and it's going to circle a bunch depending on the mass and the charge associated with it. But what is the distance the ion travels? Is it greater than Tallahassee to Atlanta or less than Tallahassee to Atlanta? And so what's the distance of Tallahassee to Atlanta? I don't actually know that. It's a 4-hour drive.
Yeah, I think it's probably about like 300 some miles, around 300 miles, right?
Yep. That seems reasonable. What I love about questions like this is the answer could be 3 feet or it could be, a light year or something ridiculous, right? That's what I love, science questions that go like that.
Well, the ions are moving when they're in there. They're moving pretty quick. So like, we're at a magnetic field strength now where like at certain MRVZs, you probably could take into account like relativistic effects. You know what I mean? That's the...
And I forgot about the wall jump in this one.
Oh,
this had to be
the wall jump is so much fun. Like, also the slide, was the slide introduced in Mega Man 3?
Slide was, or it might be 2.
No, you can't do it in 2. I know that because 2 is one of my...
Yeah.
But I think 3 is where they introduced it. But slide is like, but you have to earn it in this one. You don't get it for free.
Yeah.
Right?
Man, I like the... Yeah, so I play Halo. That's my franchise in modern gaming.
Oh, okay.
Modern-ish.
I've never actually played a Halo game in my entire life. I've wanted to, but I've always just been like a PlayStation fanboy. So I never.
It's the factioning of games back. Yeah,
it's kind of sad because it would be best if we could play them all. I suppose I could at this point, but I just don't have the time.
Makes you feel better. I never really played Call of Duty because same reason.
Yeah, I haven't played much Call of Duty myself. I'm not a first-person shooter kind of.
All right, Chad, what's the answer? Greater than Tallahassee to Atlanta or less than Tallahassee to Atlanta?
It's greater than Tallahassee to Atlanta.
Greater than Tallahassee to Atlanta. Congratulations to those of you that said greater than. You confidently voted up for this answer, and you got a nominal payout, a 3% gain on this one. It's totally worth
3%
it.
gain.
But you have pride in this, so it's traveling 300 miles in a circle.
That's right, and the thing is, that's happening in like a measurement period of like 1.5 seconds.
So how big is this circle on your ICR?
So in my estimate, I estimated the cyclotron radius to be approximately 1 inch in diameter. So how
many cycles is that to get to?
It's a lot. It's like
miles?
Yeah, it's a lot.
Holy crap.
So I estimated an ion that was traveling at 2 megahertz. So that's like an ion of 200 m/z.
I didn't realize the radius or the diameter was so small.
Well, the diameter of the ICR cell is about 2.5 inches, and we end up spreading the orbit of ions to make it seem like they're all orbiting by themselves. So small m/z ions have a smaller orbit, large m/z ions have a larger orbit, so that we minimize charge-charge interaction.
I was going to say crosstalk then. That's
it minimizes crosstalk. That's right.
So, but that screws up the measurement. You see that when it happens.
We do see that, and this is one of the technologies that's been pioneered at the magnet lab.
Yeah, it's very cool. I mean, for those of you not familiar, if you have 2 negative charges floating in space, they will repel each other.
They don't like each other, yeah.
And if they're repelling each other, it means you're not accurately measuring their distance and mass based on field, which, that's pretty cool. How does that manifest? It's just screwed up numbers? Well,
actually, this is something that's super interesting to me, and I've had some had the good fortune to know some electrical engineers in my life and some people that are far smarter than me. And this idea that oscillators that are near in frequency, whether they're in an instrument this is not necessarily totally consistent with Coulombic repulsion theory, but like sinusoidal signals, oscillators in circuits, they have interactions as well. So this is sort of a thing that happens in the mass spec. It happens in computer circuits. It's sort of like a universal phenomenon. All right, you know what?
I was going to say boss order. Do you remember this one?
The only thing I can remember is that I think I need to do Chill Penguin first.
Holy cow. Super Callahan agrees.
Chill Penguin first. Okay.
Callahan, welcome. Thank you.
We're on the same page.
Thanks for joining us. I hope they know what they're doing. We are okay with backseat gamers on the stream. We got nothing to prove. There's no pride here. We're playing. When was the last time you played this one?
Oh man, it's been a while. I like to play it occasionally, but it's been years for sure. Oh man, these guys are giving me a hard time. I gotta charge my... I think it's best to get beyond them first. What do you think?
I'll take it. It works.
I didn't know you mentioned that these guys can make us drink. Is that a thing?
Yeah, they can take their internet points and they can request take a drink.
Oh no!
Oh, and it's just for fun, right? They can request a factoid. They can unlock emotes. Chad, I didn't show you the emotes, but we got a whole bunch of them. You saw a little Carl Sagan earlier. Deity Carl Sagan. Whenever you have a euphoric knowledge gain, that's a classic one. We have some rage ones. We have some NARC ones. We got an OSHA one, which is fun. Should have popped that up. I don't use emotes enough. I really should. Especially when you're throwing drill bits into a magnetic field.
Whoa, man. Like, what emote do you use for that?
It's right here. It's OSHA. It's a red phone.
Okay.
Over.
Yeah. I was under the... I thought I was going to be booted out of the group at that point, actually.
That's a non-trivial...
March into my advisors, you know?
I mean, but those, like, you hear all the time at hospitals, like chairs being pulled into MRIs. And
yeah.
Not an uncommon mistake.
But as a result of that, in future scenarios, I've been pulled in to help others with their accidents. So, like, I've helped like a postdoc and another prominent mass spec group's lab help pull a screwdriver out of his magnetic field.
I mean, and if it makes you feel any better, you are an immortal story in that group, right? Like,
yeah, probably
shot some drill bits into the magnet.
Well, it's also, yeah. I mean, everybody makes mistakes. Thankfully, that one didn't cause any harm to any individual.
Yeah, nobody.
And people still got their data for the conference, so that was.
That's awesome. Cuddle Puppy, passing judgment here. If they go anywhere other than Chill Penguin first, they fail the fraud check. So you passed. You passed.
Dude, I would have been in trouble. I feel like that was like a...
Cuddle Puppy forgot about the mediocre gameplay aspect of
that was like a snare trap. You know?
Well, congratulations. Game 2, you still got some cred, so congratulations.
I don't know. I didn't do so hot on the Kirby, but... Yeah.
Contra wants to know, how does it work when you're analyzing a sample being exploratory, like a random soil sample? Does the machine record a number of different trajectories at once? How does it make sense of the goop, so to speak? So my favorite example of this, we can talk about this particular one, Alan Marshall's oil spill analysis with 10,000 peaks. So you just throw that in a machine and signal.
This is a great question. It's an absolutely excellent question. And to answer it appropriately, it requires a lot of a lot of back information. But the basis of it is that the periodic table, right? Every compound is made up of some unique combination of elements, right? And what turns out is that even though those elements are made up of protons, electrons, and neutrons, the way they're arranged, you've got this mass defect issue. So if everything weighed exactly what it should be, if you just added up neutrons, protons, and electrons, high resolution mass spectrometry wouldn't even be a thing. because of the binding energy, this issue of that was first described by, or first explained by Einstein, this E equals mc squared issue, this binding energy, which creates unique mass defects like the fractional mass past the decimal place, this stuff creates masses that are unique. And because the masses are unique, when we measure them accurately enough, we can say with absolute confidence, oh yeah, I don't need to go up here, never mind. I don't have the required thing to do that. But we can say with absolute confidence that these molecules are what we say they are, because there's really only certain combinations of elements that can create a certain M over Z. Yeah, I just got pounded.
That's brutal.
But I was trying to answer the question and make progress. And hopefully,
I think the question was more broad than that. So you throw 10,000 things in an instrument.
Yes.
And like, they all come out at different times. They
oh no, yeah. So we're simultaneously measuring them all at once. So they're all in the cell orbiting at the same time. Mm-hmm. But each ion has a unique frequency, and so the more when we measure those frequencies, as long as we measure them accurately enough, we can tell they're different. But assigning their chemical formula, that's what is required for, we need to calibrate the instrument and make sure it's calibrated. And once we've accurately calibrated the instrument and we have high enough resolution, we can tell you pretty accurately what's in your sample. Now, I've had the great pleasure of serving under Alan Marshall, who's the guy who invented the technique, and he would always say there's never enough resolution. So it's a little bit like your television, right? Like
greedy.
Yeah, well, it sounds greedy, but it's true, because every time we increase the resolution of the mass specs, we end up seeing new things that we haven't seen before. So
fun fact.
So far, he's been
the inventor of this technique lives about half a mile from us.
He does.
That way. So he's pretty close, actually.
Yeah, he does.
But Alan's retired as of 2 years ago, I think.
That's right.
So,
last year. He took on his last student finished last year.
I see.
Yeah.
Cuddle puppy. Enhance. Yes. Enhance indefinitely.
Enhance indefinitely. That's right. Uh-oh. I feel like I'm going to... I don't have any, no training wheels for this guy. I'm in trouble.
Oh, Cuddle Puppy had a follow-up. Games aren't for fun, you filthy casuals. So you're not playing for fun, you're playing for keeps.
Oh, no.
I mean, to follow up on the previous question, so when you say measuring the frequency, so you got these ions traveling in a circle in this
ICR cell?
ICR cell.
Ion trap?
Yeah, how do you measure the frequency of a thing that's circulating?
So the ions, we measure what's called a free induction decay. So I build these ICR cells. That's one of the things that I do. They look like a soda can, and they're cut into quadrants. In the soda can shape, they're cut into quadrants, and so there's two poles in the detection circuit. And as the positive ions pass by the pole, they attract electrons in the circuit. And that electron, attraction of electrons creates a current. So you see a sinusoidal voltage.
Oh, that's interesting.
With time. Yeah, that's how it works.
So it's like an ion-triggered transistor. Current.
So the way you build these circuits, that's an active area of research. So you want electrons to flow as freely as possible. You want them to flow unimpeded. That will create the most perfect detector. Mm-hmm. But we have to have some, there's some inherent capacitance with the circuit, and that fundamentally limits our detection sensitivity is the capacitance of the circuit.
So has anyone proposed some kind of quantum information science detector?
Oh, absolutely. Absolutely.
Is it anything promising?
There's these there's plenty of stuff. Like people are trying to detect these things called axions, which are they postulate are part of dark matter in the universe, and they don't know the frequency and they don't know the mass, but they've created these crazy detectors that are based on superconducting magnets where, it's pretty wild. They're called Atlas, I think. But these things are pretty interesting and at least interesting to me. The ICRs that I work on, these are some of the first instruments, these penning traps. You can call them penning traps. They're the first instruments to trap antimatter, like low mass antimatter, like, you know, and measure their masses. Okay, so now you guys got to help me. Like, I remembered Chill Penguin. Where do we go next?
Yeah, where do we go next?
Spark Mandrill? Is that Spark Mandrill, or what is this guy?
We need advice.
We need advice. Can we go to the audience? Can I phone a friend?
Does anyone
Is that a thing?
Who's the next pick? We'll give them some time because there's a little bit of latency on the feed. Anyone? Cuddle Puppy? You're in the crosshairs here. True gamer.
Yeah.
Be sure it's Spark, Super says. We're going with Spark.
That's where we're going. I made it through that, so.
All right. Volcano Doc, welcome back. It's always a pleasure to see you guys. Check out Volcano Doc. PhD expert in volcanoes. Also a streamer. You should check out their stream.
PhD expert in volcanoes.
Yes.
Awesome.
Volcanology. Yeah. Volcanoes are pretty awesome. Today we have the opposite of volcanoes in Tallahassee. We have 2 inches of snow in Florida. I think it's like 4 inches. We broke records today.
I don't know, but my kids were quite pleased with being able to. They played outside much longer than I thought they would.
Yeah. It's not good snow. Like, you grew up in Wisconsin, right? You remember good snow.
I do remember good snow. I mean, I also remember our superintendent of schools was like, "Oh, there's not 6 inches, then you guys are going to school." Like, they, you know. So we didn't get snow days like this, but
I mean, but they have the infrastructure.
That's true. I'm not trying to say that this was a bad decision. I think the roadways were unfit for anyone to drive this morning.
Yeah, we were debating whether we're going to hold the stream or not, but yeah, thankfully you're from Wisconsin. You can drive on ice.
Yeah,
I'm from Minnesota originally, so
oh, there you go.
Yeah.
Okay.
So yeah, but Volcano Doc has a question. Do you analyze biological samples, or are you a material scientist?
You know what I do? I all of the I do primarily instrumentation development, but all of those developments are cast in the light of proteomics. So I've done a fair amount of proteomics analysis, both bottom up and top down. So
for the general audience, what is proteomics?
Proteomics is the study of proteins. So what we want to know about proteins is, first of all, what proteins are present in your biological sample, what quantity of protein is present in your sample, and also perhaps even more information like what post-translational modifications are present on those proteins, or even structural information like which proteins are interacting with which proteins are binding partners. Who likes to hang out together?
This is awesome, boss.
It's so hard. Like, this guy gives me so much trouble, and answering a scientific question while that was
I mean, so going bigger picture. So MagLab is a user facility. People submit, applications. They have projects they want to measure. I mean, do you restrict what they can measure on your instruments, or is it just?
So because of the fact that we have these instruments that are built to be the highest resolution in the world, we restrict them to measuring samples that require these high analytical performance characteristics. So like, if you can measure your samples on a commercial instrument and answer your question of interest, then we sort of say, well, maybe you don't really need the instruments, but it is free to use them, and scientists from around the world are able to use them for free, provided they write a proposal to use them and it's reviewed favorably. So that's kind of the basics of it.
So on the FTICR, I mean, proteomics is a really big one, right? But Alan published a bunch on crude oil analysis.
Yeah.
What else weird? What do people want to see?
So we do environmental analysis. We also do a fair amount of, we've been doing more like analysis of, we've done some analysis of moon samples. Like, so NASA sent us some moon samples that they finally unearthed from Apollo 11. That was pretty fun. We do. I've done some simulated samples from the Titan's haze, like this. They're called tholins. They're like really high nitrogen containing compounds. They're pretty weird, but I like these sort of, astrological samples are kind of fun that we get. That's for sure.
So what do you see on a moon sample? What's the goal?
Well, the idea is just to characterize it in as great a completeness as possible. So this sample that we got from Apollo 11 was sealed away by NASA and was opened just recently, so that folks could analyze it with modern technology and give us like a greater picture. Like at the time they collected the sample, they knew that they needed to wait to
actually see it,
to see the full analysis, but we want to tell them what all the compounds present are that are there. So
I mean, so the hard part about that is 1969, you're throwing rocks in a bag and a tinfoil.
Yeah.
Bending it back and you're like, this won't get contaminated. Like, can you guys differentiate? I mean, you see everything, right?
We see everything, but I think we could probably pretty easily differentiate like anthropomorphic contamination in a sample. The signatures we see from these samples differ significantly from Earth's,
Oh, interesting.
Yeah, which is kind of cool.
Have you guys published this? Is this
this is actually what Alan's final graduate student was working on. So
cool.
I think he's published a few manuscripts on this, but
that seems like something sexy enough to go in Science or Nature, even if it's not an interesting result.
We struggle with getting in these high top tier journals. Occasionally we get in the top tier journals, but we're not part of the cool kids club, I would say, in that regard. Like it's not a given for us just because we have some of the highest powered instruments in the world. We don't have like a conduit to publish in Nature and Science, at will. It doesn't work that way.
I guess that's the hard part. You learn something, but did you make my life better? Like, how do you sell it at a press release?
Yeah, and I think some of those, this probably deviates from the normal. I think getting into those journals requires a pretty multidisciplinary approach at this point, and you're right, it has to be like a pretty far-reaching consequence.
I mean, they're a magazine, right? They want a press release, they want publicity.
Yeah. I mean, exactly.
You found life on.
Does anyone have any like really good suggestions for how I can take this guy down? Because I'm struggling.
I was gonna say we should look up the speed run time on this. So you're familiar with speed running, just broadly?
Yes.
Just beat games as fast as you can.
Yeah. But I bet someone's probably beaten it in like 15 minutes or something like that.
Well, that's what I was going to ask. What do you think the speedrun record is? Let's take a look. Try using your special weapons? Bruh? Do you have special weapons?
All I have is chill penguins. Is chill penguin?
Something? Press start? Isn't that how you select the view?
All I have is this guy. Is that going to do it?
Oh! Man X for Super Nintendo. What was your guess for speedrun record?
I would say 15 minutes.
It's actually 30 minutes. That is surprisingly long for a speedrun.
I see. You know what? The Wily stage is pretty long, right? I mean,
and you have to beat everyone.
Yeah, there's no like
there's no glitch around it.
I don't think so.
Good to know. You guys are curious. The speedrun is 30 minutes and 54 seconds. Cuddle Puppy's comment on using the penguin gun. It's going to do more than shooting corn nuts at it, I bet. The default
is that what the blast, like whatever is default blaster is corn nuts? Is that the?
I don't think that's canon. But
I think it's good enough for me. That's pretty funny. Corn nuts. Corn nuts are a high quality, snack, by the way.
Yeah, but not a great projectile.
No.
Cuddle Puppy was following up on what you learn about proteins. 1, what proteins are present. 2, quality of the proteins. 3, what structural information. And 4, can they make you jacked?
Yeah, I don't know about that. Yeah, I'm not sure.
That's fun. Proteomics.
Yeah.
I mean, so what's the sexy thing to measure in the field right now? Is it biosamples?
I think the sexiest thing in proteomics is what they call chemical biology. So people are looking for ways to truly understand like what the interaction networks are occurring in cells. So like,
So you want to try?
obviously proteins are like these things are like, they do a lot of the heavy lifting in terms of actions in the cell, and they're responsible, like when they're not functioning correctly, they're responsible for disease states. So what you want to know is what are they doing in the cell? Who are they interacting with, and for what reason? And so if you can come up with a chemical strategy that discerns binding partners, then you're at the forefront, I think, of proteomics at the moment. That would be that's my 2 cents, at least. I mean, certainly the drug, you know, a lot of people, one thing that hits close to home is like these biologics. Like, I think GLP-1 is one of these biologics, Humira, like these biologics that have emerged from drug companies to treat this wide range of chronic autoimmune diseases that people have. Like these drugs that shut down your immune system from attacking itself, they have to be characterized, and they're not traditional small molecule drugs. So these things, that you have to approach the analytical chemistry from a different perspective, and so mass spectrometry is one way to do that, you know, especially in cases where they're conjugating like small molecules to, you know, these drug antibody conjugates, things like that.
So yeah, so it's not just structure, but like mechanism of action, how they interact. And
Yeah,
it's a lot of info.
it is. It's a tall order.
Well, so the follow-up question, and X-ray crystallographers have this all the time. So if you want to solve a structure of a protein, historically what you do is you take a whole bunch of that protein, you grow a crystal, and then you solve that crystal structure. So
Yes.
feeding solid-state sample. And the critique they get is protein in a crystal is not protein floating around in water. The structure might be different in those two circumstances. So do you guys deal with that with gas phase?
We don't have that problem. We kind of have the opposite problem. So like when we think about proteins, we have less of an issue with their disordered domains. But our resolution on structural information is really low. So like if we can chemically cross-link proteins and then measure them, and then the resolution of that is terrible compared to X-ray crystallography. But we can at least confirm binding partners, or we can confirm binding interfaces. So and sometimes when you have regions of a protein, we can make measurements that might be more biologically relevant in that we don't have to truncate the protein and only use a certain section of it. We can use the whole protein. We don't, you know.
How do you tell binding sites or binding pockets?
Well, yeah, I mean, it's strictly through inference, so we can't say absolutely, but
unless you structurally change the protein. And see if okay. That makes sense.
So typically if you took a cross-linking approach, there's different types of mass spectrometry approaches that you can use to do structural characterization. But the most common ones would be affinity mass spec, like affinity purification mass spec, where you bind a protein of a protein target to a bait molecule, and in that case, you're just going to end up with targets that bind to that molecule. You can't say much else than that, but sometimes there's a whole host of techniques that come into play. Like cross-linking, you can do this with cross-linking mass spec. You can cross-link. Hopefully, you get a whole mishmash of stuff, but hopefully you get meaningful information of which proteins are bound to which. And if you get enough coverage, you can say that a certain interface must have been within a certain number of angstroms apart. And so because your crosslinker is only spans a certain distance. So
how's your thumb doing? You got some button mashing going on.
Yeah, I'm trying. I'm struggling. This is like I feel like I've reached a brick wall on Sparkman's stage.
No worries. I mean, we could switch stage, we can switch games. It's whatever you're having fun doing. Like, this is all about you enjoying while talking. And Chad, if you guys have any questions, Chad's happy to answer them. We're talking mass spec, we're talking about proteomics, we're talking about measuring things really, really accurately, measuring mixtures of things using mass spec, and in particular ICR, Fourier transform ICR, which is kind of cool.
We can open up the discussion to topics other than that as well.
Yeah, I was going to say, let's do broad expertise.
Right.
I just use the buzzwords from your bio. That's why
there you go. Sure.
But yeah, if you guys have any questions other than which proteins will make you jacked, we do not have that answer. Thank you, Pedal Pup.
I heard creatine's the way to go.
It was back in the day. Is it still a thing?
I don't know. I'm not sure.
I'm sure there's much better things now. Oh, yeah. Maybe try Penguin on the final boss?
He's not. That's the worst part, Ken.
Oh yeah, this boss. Sorry,
he's like the middle.
Boss.
Yeah, he's the mid-level boss. Like I'm struggling.
King Willie says this game is cool. Absolutely, Mega Man is a classic.
All right,
I haven't played any of the newer modern ones. But
okay.
right off the bat,
Maybe I can. Oh,
that's doing some damage.
Is it?
Yeah.
I hope so. Take that, buddy.
You get all of them.
Oh, come on. I know, he's got me.
Cornered. That was pretty good. He's a quarter of the way down with like 3 hits. That might be the strategy. One more shot, then we change.
One more shot, and we'll change it.
What are you gonna do next?
I don't know.
Do Elden Ring. Get wrecked on that.
I will be destroyed on that. I think.
Yeah, you don't really know until you actually do the playing and talking what it's going to be like, and
it's a challenge for me.
Nobody has tried Dark Souls or any of the franchise yet.
Oh my gosh, yeah, that requires your utmost concentration. And the worst part is I'm on like I'm on the hardest level of. People claim it's the hardest level of the game. That's probably no coincidence that I put the controller down. It's
awesome.
You know, I think this is a great way to. One of the things that I found growing up, I don't know if you found this, but like video games were sort of stigmatized as something that weren't cool. They weren't, they were a waste of time, and maybe that's true, right? But they're still like, I think they're very enjoyable, and I think that stigma is going away. I certainly wouldn't. I haven't taught my daughters that way, but
yeah, no, I think it definitely has. The average age of gamers is like 30-something now, right?
Oh,
That's our generation grew up and said, no, these games are fine. So yeah, that stigma definitely went away. At least a little bit, because the NSF is okay with this as my broader impact. So
okay, there you go. As long as the NSF's okay with it.
Yeah, exactly.
You're good.
Some
Why is
don't
it?
get it. No, it's hitting. It's doing damage.
Is it really?
I think so.
Oh no.
It's halfway down.
I think that's just my.
Yeah, no, they're hitting.
Okay, good. I think that's my power level.
Is it?
Yep. Oh, that hit. Can I get him? No. I ran out. This is like.
Oh, never mind. That was not his meter. I'm dumb. All right. I can't tell.
Oh, look at that.
Flashing. It seems like sometimes it's iframes.
Wow.
I agree. Hitboxes, man.
You had to lay the gauntlet down and say that we were going to switch game. So there you go.
It wasn't a judgment, but congratulations. Good game. And you still have to do more. What is this? That's not even.
Oh, that's like halfway. Yeah. Ooh. Now I have to. Now I'm just gonna sit.
Your daughter gives you any shit. Make her play this game.
Yeah, the kids these days.
Exactly. Sure, there's no stigma, but also modern games.
Yeah.
Easy setting. absolute nonsense.
Yeah, and that's the thing that's cool about the FromSoft games, right? You have no, well, at least with Demon Souls, you never had a tutorial, you never had, you know, they just throw you in the deep end.
Apparently Cuddle Puppy can speedrun Dark Souls 1, except they're not a scientist, so yeah. Have you seen some of those no-hit, like, speedruns? They're crazy. That's
super impressive. Like, Dark Souls 1, like, what is it? The dragon in the DLC, I forget what is his name called, I forget. But that dragon, that's like one of my greatest achievements in gaming, is because that dragon could one hit you essentially, and the area of effect damage that it would cause when it would swoop up and blow fire down on you.
You farming health right now?
I'm trying to, because I'm not willing to die at this point.
Yeah, no, veteran move though.
Is this like, this is anti-Twitch streaming? Like,
no, people. I mean, Twitch is great because like people beat Dark Souls with a rock band guitar. Like,
okay. So there's
no rules.
We're in good company then.
Black Dragon Calamite.
Yeah, Calamite. And then the worst part is you end up killing him, and then if you forget to chop off his tail at the end, you miss like an amazing weapon in the game. Like, that was good. That's fun.
Wait, yeah, that happened to you?
No, I actually did get the special dragon tail weapon that...
What's the drop rate on this? Jesus.
I don't know, but I feel like I'm getting cheated here. I'm just gonna go forward, I guess. Oh, what? What a jerk.
Then he's back. Yeah, that's the other thing about these original games, is that bad guys...
Oh, look at that. Like...
The bad guys didn't, like, disappear. They just reappear when you get them off screen.
Yeah. This is...
No despawning these.
Now I have to make it to the actual boss, and if I don't, it's gonna be a great disappointment.
What's the save point in this?
I don't know where the save point is in this level, honestly. Those guys are annoying.
You should refill your... Does your other character have their shooter?
It refills automatically.
After the boss. Okay.
Well, I think that as opposed to previous Mega Man games where you had to pause it and like select the gun and then collect the power up, in this game it automatically...
Oh, that's a nice feature. Holy cow.
Yeah.
Old school, apparently. All right, we should do another prediction. Which one do you want to do?
How about you pick this time, Ken? Hey.
Let's do in a vacuum. All right, we're going to do another prediction, ladies and gentlemen. If you're not following us, click the follow button. 1, because we like our numbers going up. But 2, it gives you 300 standard internet unit points that you can spend on a question. You can gamble how confident you are in the science question. For our predictions, we don't ask gaming questions, at least not typically. Instead, what we'll do is we'll ask science-related questions created by our guests. So in this one, we're going to ask a question about mass spec.
Oh, look at that. I got it.
Mass spectrometry is conducted in a vacuum. So not a solution, not a polymer matrix, conducted in a vacuum. True or false? Is this an always statement, or is this a usual? I guess I don't want to give away too much with this one. Is there anything you want to add to this question?
This is an always.
All right, mass spec is always conducted in a vacuum. True or false? And so depending on what you guys know about mass spec, or what you've learned from the discussion thus far on the stream, or what you've learned from Chad's Mega Man X skills, I don't know how that would help you with this question, but if you guys have a guess, put it in there, gamble your points accordingly. Mass spec is conducted in a vacuum, and mass spec is taking things, ionizing them, putting them through a magnetic or electric field, and figuring out what the mass of those things are. Do you have to do that in vacuum, or can you do that in other mediums? Always is the question we're putting here.
All right, I feel like can I do it?
All right,
question.
Any advice on this, boss?
Oh, I think this guy. Yeah, I remember this guy. I think I can cheese him.
Yeah, it's hurting him. Not cheesing if it's within the rule set.
Is it? I feel like I'm cheesing him.
Oh, too easy.
Yeah. All right.
Oh, ladies and gentlemen, we got some GGs. That was a well-deserved win. You grinded through that level. All right, mass spec is conducted in a vacuum. True or false? Always true or false. Put your predictions in there now. Yeah. Man, we are up to 855 followers. It's pretty solid for a science stream that goes twice a week.
Yeah, man.
I'll take those numbers. It's what, 8 or 9 follows per stream? We will take that.
Congrats.
All right, last seconds. Hey, party people. Misadventures, welcome back. Misadventures, we talked about doing mass spec on Apollo 11 rock samples earlier, which is pretty exciting. So we got some astro inside our mass spec and our magnetism, our mag lab related science questions. All right, Chad, what is the answer? Mass spectrometry is always conducted in a vacuum, true or false?
The answer is true.
Always.
Always.
There's no examples of solution mass spec. Which is a shame, because Cuddle Puppy had a dark horse bet of false. It would have been a 200-to-1 payout. Cuddle Puppy won if the answer was false. Everyone else said true. Thank you all for answering true. Congratulations. Yeah.
Well, and truth be told, I was once invited to give a talk at the American Vacuum Society, which triggered a fair number of jokes about how vacuous my personality was. So
it's on your resume.
Yeah, it's on my
resume. And so why in a vacuum? Why does it have to be a vacuum?
So because collisions with neutrals will actually strip charge off of ions, and if we want to steer ions and trap them, we have to do that in the absence of neutral molecules. Making our measurements is in an extreme vacuum that's like not greater than the deep space, but greater than most portions of outer space, because when ions collide with the neutrals, they're destroyed.
So if you had to do the spectrum of vacuum powers, so your high vacuum, what is that? How many 10 to the minus 5?
Yeah, so 10 to the minus 5 torr is for like an ion trap, like a linear RF ion trap. So that's a radio frequency ion trap. That's Wolfgang Paul, the Paul trap. That's something, a Nobel Prize was won for that. But we do ours at like 10 to the minus 11 torr. So
wow.
We're doing it way low. But the kinetic energies we're working with are in the kilovolt range. So we're talking like 50 keV, which is pretty high. One single collision destroys a molecule at that kinetic energy.
So Cuddle Puppy, I do all my mass spectrometry in a Dyson.
You know what? The Dyson...
So if we had to do if you back of the envelope or back of your brain calculation, a Dyson vacuum versus 10 to the minus 11 torr, what magnitude difference would that be? I don't know what a Dyson pulse.
It's probably similar to a rotary vane. Like it's probably, I don't think it can do millitorr. I don't know. Can it pick up a bowling ball? Like they used to have those commercials where you could.
I think that was a Dyson, right? Let's it was a bowling ball. What would that take? What is that? 10 to the minus 3? Maybe?
Yeah, probably that's it. Yeah. So 8 orders of magnitude.
So it's 8 orders of magnitude stronger vacuum to run a mass spec on their particular system.
Our magnetic field, I'll hand out this factoid for free.
Unless somebody wants to buy it with your interview. All right, go ahead.
Our magnetic field is the equivalent of like 18 sticks of dynamite. So the stored potential energy in our magnet is equivalent to 18 sticks. Or you could convert that to 81,000 pounds traveling 100 miles per hour on the freeway in a semi.
How do you translate a magnetic field to potential energy? That's just the force of it?
Yeah. So it's electrical potential energy. So the amount of current that's stored in the coil.
In the coil. Okay. Yeah. It's not the magnetic, it's the electrical. Yeah. That is
pretty wild.
What was the number again? Say that again.
Either 18 sticks of dynamite or 81,000 pounds traveling at 100 miles per hour on the freeway.
That's pretty intense.
So now does anybody know who's next? Is anybody on the stream that can tell me
who's next? Who's the next boss?
And the question is, can I do it? Do I have the
Is that our next prediction? I mean, so that's the amount of potential energy in those coils. Obviously, when they explosively decompress, like there's somebody that died at the mag lab during that, right? There was an incident.
Oh yeah, that incident. So I was not here for that. I was not employed. I was actually employed at in California at the time. But that person, my understanding is that there was actually a pressurized water circuit. So that they took a flange off of a pressurized pipe, and the flange, they thought it was depressurized.
I see.
Yeah.
Oh, it wasn't even a magnetic. I thought it was.
It wasn't a magnetic field that caused it. No, it was actually a pressurized pipe. So,
all right, good to know.
Water.
All right, no one's making comments. Cuddle Puppy, you know what level it is. No?
I'm gonna guess. I think if I had to guess, it's gonna be this what's it? The armadillo guy. Go for it.
All right, we'll see. Armadillo guy, here we go. I never beat this game. Cuddle Puppy, you're nonsense. He did a judgment on his first. Oh, wow.
Yeah, this part's crazy.
It's fun. It's very, I don't know if you ever played Aladdin for the Super Nintendo.
Oh, yeah, Aladdin.
The lava.
So there's an era where the Disney games were awesome.
Oh, man.
And like, I mean, DuckTales, that game, I've sunk a lot of hours into DuckTales. I love DuckTales. But Aladdin was also one that I really liked.
So Eugene DePrince beat Aladdin on stream. We timed it. So he was like 19th ranked, but he's never submitted his run.
Really?
So yeah. One of the chemistry professors, Eugene
That's
DePrince,
amazing.
Yeah, on stream did a speed.
Oh, I missed the... I think there's...
DuckTales. Contra said DuckTales. Did you ever play that for the NES? Oh,
the DuckTales is the best.
Oh my god. You bust that one out if you want. We have all of it going. But yeah, if you guys have questions for Chad, he's happy to answer them. We are an hour and a half into the stream. Time flies while you're having fun and beating some Mega Man. Michi Moki has redeemed a request a factoid. So you wasted one on Dynamite. What's your next factoid? Michi Moki, welcome to the stream. Thank you for joining us. Thank you for the request of a factoid.
So in the case where we've measured world record our spectra are world record breaking, we routinely detect over 500 peaks per nominal mass. So typically on a commercial mass spec they might see one or two, and we're seeing like 500. So we might see in a spectrum like that, we could easily see over 300,000 peaks in a single unique analytes, unique chemical species in one spectrum, which, I mean, there's obvious implications for that kind of thing, right? Like, it's not easy to interpret that, but
I mean, so
that would be my factoid.
Inject a random sample, and you can see there's 10,000 different things.
Yeah, so that would be a crude oil sample.
Yeah. I mean, so if you just took like dirt from our backyard here and just throw it in the mass spec, well, what do you think you'd see in terms of number of things?
So we would see probably what we consider a dissolved organic matter signature. Mm-hmm. So that
Oh, that's interesting.
I wanted to try to get behind there so I think there's a secret behind there.
Yeah.
I think.
That's a fun glitch. Yeah. Sorry, anyway, the sample from my yard.
So we'd be looking at dissolved organic matter. So all these, the microbiota that live in the soil, they're essentially, we'd be analyzing their excrement and all the decaying matter that makes up the soil. And
that's kind of fun. You have metabolomics for.
Oh yeah, well we do
shit.
Yeah, that's right. We do metabolomics as well. I mean, we sort of cast ourselves as the jack of all trades kind of analysis. So I did it again. Oh, I made it. I got it.
And that makes this easier.
There
you go.
Yeah.
And now you're not in a hurry.
Yeah, I can just take my sweet time now.
I mean, that's fun. So I guess this is going to go to one of my canned questions that I ask every single guest. But like,
Okay.
if you spit in your mass spec, like, have you done that? Have you measured your own saliva?
You know what? I have not measured my own saliva. I've measured, as a graduate student, I've measured my own blood.
Anything interesting?
I mean, I didn't find any. I didn't come to the conclusion that I was suffering from some strange illness or anything, but
I mean, well, that's an interesting question. How good would this be as a diagnostic? Let's say if every doctor in the world could run this locally and get 10,000 peaks.
yeah, that's a good question. So I think the interpretive, the analysis of the data lags behind the ability to acquire it. So like making it so I think, you know, maybe algorithm development, being able to make proper use of the accuracy of the measurement, those kinds of things, from a philosophical point of view, they lag behind, but this is common among most analytical chemistry fields. Like the ability to acquire data far outstrips the ability to analyze the data, and so
I mean, that's an intriguing proposition. You guys could take, you know, samples from 10,000 people and just like the ones with diabetes have this particular signature, right? You think like there'd be enough data to do that?
Absolutely. So we've done some. Oh, sweet. Got it. We've done some clinical work, but since we're really in the business of proof of principle and sort of one-off measurements, we're not doing like large-scale clinical studies. I think would be outside the scope of the funding mandate from NSF.
Yeah, that's fair.
So in that regard, but we have done some blind studies where we've looked at like, that was pathetic. See, that's a direct consequence of multitasking. Do people here believe multitasking is a thing? Because I don't know that I don't think it is. Like, I require every ounce of my being to play this game, and I feel like I'm sacrificing a little.
You're doing fine. But like theoretically, if someone was able to do that data, so they took FTICR and they're like, here's 10 billion people, here's every condition they have.
Yeah.
I mean, just saliva alone should.
So there's a lot you can learn from bodily fluids, not just saliva, but I forget the proper scientific terminology for like the fluid of your eye, but people learn like a ton of stuff.
Ocular fluid.
Yeah, like there's actually like a fancy name for it too, but it doesn't matter. But people learn a lot from that stuff.
Ooh, look at that.
I didn't really need
Well
it.
done.
I didn't even need it, see?
Vitreous humor.
Yeah, that's right. Vitreous. Yep, exactly. But you can learn a ton of stuff about people from that.
That's pretty cool.
I personally learned that.
What's the
I don't know
choice
if
on this, boss?
Oh, I think we have to use one of our recently acquired skill sets. eSpark. I think this is the only way. This is the way.
This is the way.
This is the way. Got him. So I recently learned that you can, apparently you can detect if somebody has heart problems just from like fluctuations in their voice, which is pretty crazy. See, this is where I would rely on like save states, and I'd just go back to where I saved
Try it again.
Full health, but I pathetically...
It was a valiant effort. All right. Keep playing, try something else. What do you want to do?
As long as it's interesting to the audience, I'll give it one more go.
We don't care about the audience. They're here for the science.
They're here for the science?
If they came here for the gaming, they would be woefully disappointed every single stream.
Oh.
So you're saying Bobcat Goldthwat's heart has been failing for 40 years?
That's awesome. Yes, that's exactly what I'm saying.
Misadventures is here for the NARC, so none of the other games you play matter.
Oh, he's like wanting to see how I... Yeah, like I was just telling Ken before we started, he gave me a really, a very nice like coaching session.
Yeah, spoilers, I give every guest a walkthrough on NARC, just give it a try to do jumps and rockets and whatnot.
But I tried to explain to him that, I'm past my prime already. So
Every single guest is past our prime in the stream, so you don't have to feel bad at all. Oof. It's a lot more pressure this time.
Yeah, I'm just zooming through because I don't want to. Oh,
Spikes, zero or more sun spikes.
no, yeah.
All right. Oh, but anyway, the mass spec question about diagnostics and whatnot and determining structures and species. So one of my favorite questions, I don't care about the audience on this, is
Okay.
movies or TV
Ignore
shows that give your discipline or expertise right and wrong. So a surprising number of shows actually use mass spec.
I've never seen a show get it right.
So what's your problem with how they do it?
Well, they make it seem like they get they put the sample in the mass spec and they're like, oh, it's this. And it's like, there's nobody who, I don't know. There's very few people who have the ability to do that. And like, typically we have to collect the data, do some analysis, perform some, you don't get the answer instantaneously, but I recognize for the shows, the purposes of the television show, they have to get an answer right away. So, but
I mean, but in their so like they do mass spec at airports, right? That's how they sample the.
Well, so actually I don't know of any airport that does mass spec. So they do something closely related to mass spec. In fact, it could be described as a poor man's mass spec.
So how do they do?
Which is called ion mobility. So they simply do. They look at mass spec. One of the things we haven't spoken about is that mass spec measures mass to charge ratio. That's what we're actually measuring, physical property. Ion mobility measures size to charge ratio. And they're doing that, they're measuring the size to charge ratio of an ion, and they're doing that very rapidly. The process doesn't take as long as mass spec, and it's an analytical technique that's more matched to the throughput that they need for an airport. But it's very similar. Like, so size to charge, you can imagine if you think about the physical. Yeah, I know.
No.
If you can imagine the physical
iframes.
Yeah, exactly. I know. That was like blatant exploitation of iframes.
That was good. It's beautiful.
But the physicochemical properties, like the size to charge and mass to charge, they're not completely orthogonal. So they're more like at a 30-degree angle. So there's overlap between mass to charge and size to charge. But this is good enough. It's sort of considered good enough. Mass spec would. Would I sleep better at night if people use mass spec at the airport? Absolutely, but analyzing a mass spectrum is much more difficult than analyzing the ion mobility spectrum.
I mean, but in their case, they're looking for particular things. They
That's
know
right.
What they're looking.
That's
for,
right. They've got narcotics. They've got explosives. They've got those are the ones they're looking for. So they're keyed in on those things. And there are some, there are known contaminants, and those known contaminants, when they overlap in an ion mobility spectrum, that can actually.
Oh no! That was brutal.
I timed it badly.
And so my undergrad organic professor would make jokes about like dusting coworkers' luggage with like dinitrotoluene, right? Like a dinitro.
Yeah.
Would that still show up on ion mobility?
It probably would be, and I think that you would be stopped in an airport for that sort of thing for sure. Yeah. You'd be in some serious trouble.
Good to know. Yeah. All right, so none of the TV shows get mass spec. I guess my guess for the biggest violator is the CSI, right? They throw stuff.
Oh yeah, that's right.
There's nothing that's done it right that you're happy with?
Not that I've seen, but I'm like kind of an elitist if you haven't picked up on that with regard to mass spectrometry, like it's like I have this sort of very specialized knowledge, and so I'm pretty critical about that sort of thing. So,
has its use ever surprised you in a show or movie? I mean, like forensics is an obvious one. Airport security, maybe things related.
I've never seen it used outside of forensics in a television show, but maybe it's just I don't watch a terribly large amount of television. Like,
good.
Yeah. Well, we'll see. I'm already hard up here.
Oh. Man.
guy's tough.
No.
Oh, yes.
All right. Catching up on a Contra question. What are the new small things that were discovered after the latest resolution upgrade, and what's the smallest thing we've seen? I guess you're not looking for smallest thing. You're looking for smallest differences.
Smallest differences.
What is your higher resolution enabled that the previous gen of tech wasn't able to see?
So we can see stuff that's around a quarter of a mass of an electron apart. So and that's at masses of, you know, up to 800 m/z, maybe even bigger. So that's kind of the state of the art. We routinely measure resolutions on the order of millions. So it's really hard to think about. It's a bit like, you know, I guess it's one like way to think about it in a really down to earth sort of way is like standard definition television to maybe like, you know, ultra HD television, right?
I mean, so indirectly you're testing relativity, which is kind of cool.
Yeah, so actually, in one of the major Achilles heels of mass spectrometry is that if you have a structural isomer, you should not be able to tell these molecules apart. However, in theory, like if you had a high enough magnetic field, so we don't have this right now, but if you had a big enough magnetic field, you could literally tell the differences in bond energy and tell structural isomers apart because of the E equals MC squared idea that bonds even though they're the same number of atoms, all the same atoms, same empirical formula, because of they're arranged differently, the overall mass will be slightly different, and so it's pretty wild stuff. Theoretically, no one's ever shown this. Like, we would love to show this sort of thing.
How big of a field would you need?
I think for some really small molecules, we'd need something in the neighborhood of like 100 Tesla, maybe a little bit more than that. We don't have a field that high yet.
I was going to say, at least not a static field. You need an explosive. Man, that's intense. So those of you guys that aren't familiar, like structural isomers, so H4, that's methane. It only has one structure. There's the only way you can do that. But when you go up to C7H16, there's like, I don't know, 1,000 different ways. There's something ridiculous. The number of ways you can put those atoms together. Right. Not 1,000. It's going to be like 60 or something like that. And so mass spec, I mean, it tells you the mass, but all the masses of those 1,000 are the same, right? So what you're saying is the relativistic change due to the connectivity where things are bounded to each other could be discerned under a sufficiently large field.
That is correct.
That's crazy.
It would be a test. It would be a direct test of Einstein's theory of relativity.
So how does the binding? Yes. Depends on the nature of the bonds. That's
because some of the chemical bond is converted to energy, and that's how it works. It's literally an embodiment of the E equals MC squared equation, which is pretty crazy to think about, and pretty cool to think that we get to work on these types of problems.
So what's the strongest static field right now? I don't even know.
The 21 Tesla is the world record for ion cyclotron resonance. There are supercon magnets. There's a project in the works for a 40T all supercon magnet. There's certain criteria that are needed for homogeneity for resonance type magnets, like for NMR or MRI or ICR. They all fall into this category of resonance, and so I don't know that maybe in my lifetime we'll see a magnet that could do that, but there's a lot of I don't know. There's a lot of development required to get there.
And yeah, for a general audience, there's some really fun, like just record-seeking magnetic fields, right? Just trying to make bigger magnets. And there's two different classifications as well. There's many, but like the general ones are static magnetic field and then like transient magnetic field.
Yeah, pulse field magnets.
Yeah,
that's right. Yeah.
And so like static field, the record's what, like 50 Tesla or something like that? 40 maybe?
32 Tesla is the all supercon static magnetic field. Like, so the pulse field magnets go over 100 Tesla at this point in time.
And those are the single, like, explosive
Yeah,
ones,
well,
or
some of them are explosive, some of them are generated through other means, but hey man, this guy's dogging me. What the heck?
got him. That was good.
Yeah, we'll see. Maybe I need another drink.
I got you.
No, I'm just teasing. I'm teasing because
You want one more?
I think I could do one more.
Got 3 hours.
Oh,
Use this bottle opener that Eugene DePrince brought back for me from his trip to China. I don't know the name of the brewery, but here it is.
all right. So it's go time.
And there's this awesome, I've seen a visual graphic of magnetic field, like this neutron stars or something, or a supernova will create XY like 10,000, like something ridiculous, right?
Yeah.
But like
that's
atomic bomb, nuclear bombs, those, every explosion creates a massive field.
That's right. Yeah. And I think, you know, the Earth has a.
Well, you can hit him while he's...
Yeah, you can, but now I blew all my.
Back to corn nuts.
Yeah, back to corn nuts.
Sorry, cuddle puppy.
Sad and pathetic.
I mean, so when you guys do a mag lab renewal, do you propose just bigger and bigger ICR magnets?
We propose upgrades to the instrumentation. We propose novel ways to use it and things like that. But yeah.
So the recent upgrade, was that part of Kiki's hire? She wanted to revitalize one of the instruments you guys weren't using? Is that...
No, the recent upgrade started before Kiki was hired, and it's been going on for about. I've been working on it for about 3 years, so it's a pretty big deal. But it's, I don't think I think I've reached my.
All right, what do you want to do? We got
limit.
Battletoads, Double Dragon. We can do Simpsons Arcade. What are you in the mood for?
Let's try out some Battletoads.
All right, it is time for some battle, because we didn't have a hard enough game. We're gonna go to another really hard game. So classic. Switching over to Battletoads, ladies and gentlemen. But in this case, we have infinite lives, so it's a little more forgiving. Mega Man X, I cannot get cheat codes to work for some reason.
You know, all my greatest gaming memories are of couch co-op. I don't know, like, I feel like my kids game in their own way now. Like, they do Roblox and all these other things, but couch co-op was like, for me, those are some of my happiest childhood memories, are playing games like with, you know, 2-player games with my friends, you know, that sort of thing. But
man, but that like Halo 1, when you had the first person shooters, screen watching was a very big thing.
Oh,
like,
yeah,
that was
yeah.
a massive cheat.
or like what is it,
Bond, yeah, 007.
That's the GoldenEye.
Yep, that was the big one.
Oh.
Like, you lose friendships over that kind of shit.
You're watching my screen.
What are we drinking tonight? Tonight we started out. Actually, Chad, go ahead.
I like the IPA beers, so we're drinking High Lie, which is a great Florida IPA from Cigar City.
Cigar City is they're located in Tampa.
Yeah.
So, and then we switched to Sierra Nevada Pale Ale, which is what we're drinking now. Fun green screen effect. Yeah, hanging out, relaxing, looking outside. There's snow on the ground. Did you scrape your car when you had to come here?
I did. And it was like, it was a lot. It was a lot.
It's a couple inches. It was crazy.
Yeah.
What'd you use to scrape your car?
I have, believe it or not, I have a scraper in my car.
That's amazing.
Yeah.
Is this residual from Wisconsin?
I think so. Yeah. I'm one of those guys. I never throw anything
I didn't.
away.
I grabbed like one of my kids' toy shovels from the beach and like, you do your best. But yeah, it's crazy. It's supposed to get down to 26 degrees tomorrow. So yeah, those of you guys not familiar, Tallahassee, cold front came through all through
Oh,
the southeast
man.
United States. In Tallahassee, we had school K through 12 was canceled as of 1 o'clock yesterday, I think was what
That's
happened.
right.
And then today it was canceled all day. Tomorrow it's canceled all day. Tomorrow morning it's going to be 26 degrees, which is kind of crazy for Florida.
So this is like, it's hilarious. We're playing video games on a snow day. This is our snow day.
Absolutely. I'm glad. I'm glad you said yes, and I'm glad you were willing to brave the snow and ice because
Yeah.
it's been a month since we streamed, so we have a break over the holiday. Right?
Yeah,
and then
yeah.
getting somebody on like the first week of classes is rough. So I'm glad you were able to join because it's good to be back on stream. Thank you all for joining us again. It's Ask a Scientist Gaming. How's traffic with the snow? How are the roads?
There was not much traffic. I did a little fishtail on the way here. I've got a rear-wheel drive pickup truck, and so but it was good.
you were surface streets? You didn't have to go on the 10 or anything crazy?
I went on I-10. Yeah, I'm about 20 minutes away, but I live out off of Buck Lake Road, like Baum Road, like way out there by
the Amazon.
Yeah.
But it was
got
okay.
him.
Was the fishtail on the 10 or was it
No, it wasn't on 10. I mean, 10 was pretty good. It was on the way.
Misadventures? The 10 you transplant?
On the way to 10.
I am not familiar with why the 10 is that not a local thing? I don't know.
I-10, Interstate
I-10.
10.
Oh, I-10? The 10. I don't know. That's what we call it in like LA, right? It's the
Yeah.
man.
There's only
95,
one
495
interstate. There's
Minnesota.
only one interstate in Tallahassee, so we could use the to describe it, but
Mega Man X was too hard, so you switched to Battletoads.
yeah, but he's got Game Genie. This is a no-brainer.
Man, I tried so hard. If anyone knows an emulator for Super Nintendo that works with Game Genie codes, they are so hit or miss with BizHawk and SNES 9.
And the other thing too, like who knows? Maybe my memory of this game is better than the.
Oh man, Cuddle Puppy's comment. Fishtailing is just boomer speak for drifting. You're about to go viral on TikTok for your base skibbity driving. you weren't fishtailing. You were drifting, sir.
Really? Okay.
I understand most of that. How's your slang with your kids? You got a distribution of ages?
I don't know any of this.
Skibbity toilet and whatnot.
I don't know anything about Skibbity, nothing. I heard this weekend about W-Riz. I don't
know what that is. So
I didn't know what it was either. So Riz is apparently some kind of slang for charisma, and I don't know what you put W in front. I don't know what that means, but they tried to explain to me that it meant some kind of like extraordinary level of charisma. That's what I was told.
All right, good to know. So you don't feel like you're missing out on anything.
Which I was hoping to draw upon for this stream, but I feel like I'm simply embarrassing myself at every turn.
Riz is charisma with probably 4 win.
Okay.
Riz.
Yeah, I don't, like the amount of slang terminology that I keep up with is near zero.
I mean, as long as you're not actually trying to keep up with it,
yeah,
you won't be ridiculed necessarily.
Or what's the other one? Cooked. They're always saying cooked these days. I'm certainly one of the folks that I've been described as being cooked. I'm cooked.
I don't know what that is.
I think it's a way to say that you're basically, you're done, right? Like you're past your prime.
Fair. Cooked equals screwed, dead, done.
Yeah.
Right, so you should just start using them. Use them incorrectly, use them correctly. You'll completely ruin it for your kids.
I think they've been sufficiently embarrassed by their dad at various points, but I know that the family dynamic is an interesting one, right? Like my youngest daughter is a very strong-willed individual, and she's certainly embarrassed me at various points in time. And at one point, I was like, you know what? There's gonna come a time where I'm gonna embarrass you.
So your daughter's into science? Do they?
You know what? My youngest daughter is totally into science. She loves it. My middle daughter is too, but my eldest daughter is more into music. She likes to play the piano, and I certainly hope that there's a career for it in her, but she really likes to play the piano, and she's reasonably good at it.
That's fun.
Yeah.
Man, I recently learned that FSU apparently has one of the world's best piano tuning, I don't know what they call, like workshops or something like that, like tuning and repair.
Really?
Yeah, I didn't know
That's
this.
cool.
So, it was a professor I met. I gave a talk about detecting generative AI on exams, and that was like the hub, and like he came up afterwards and talked to me. He's going to come on stream at some point. I'm going to have to search him down, but
Oh no.
I want to go. I want to go see his setup.
That's
Apparently,
gotta be
just
cool.
like rooms and rooms of pianos at different stages of deconstruction and like rebuild and all sorts of stuff.
That
and
sounds amazing.
apparently, they fix pipe organs, which is kind of crazy.
That's pretty wild. Like,
And that's in close proximity to us, and we don't know that exists. Like the
Hey.
world's best whatever, man.
that is, I mean, you know, you get you get siloed in, and you just
Yeah.
do your thing, and
Well, that's one of the reasons I love this stream, because I learn about so like we're closely related. I mean, we're chemists, right? But like
Yeah.
when I get an expert in music or
yeah, that's great.
ecology or whatever, like I learn a bunch.
Yeah, you're multidisciplinary. You're
At least I pretend to be on stream. So cheers, everyone. Thank you for joining us in our multidisciplinary discussion effort. How's Battletoads treating you? You're happy?
It's great. You know, Game Genie is a wonder. It makes me, nobody noticed that I've lost like 50 lives already.
I don't remember
It's not
what
gonna-
it was. It was 3 lives plus like 5 continues in the
Okay.
original or something like that.
Yeah. And it's a wonder that I was able to make it this far when I was a kid, you know.
Oh man, wait till
Although-
you get the speeder bike.
oh.
There they are.
Oh.
But it's okay. You have infinite lives. It's just memorizing from here.
Okay. Well, we'll see.
But if you guys want to distract Chad from his speeder bikes, let's do this. Let's talk about mass spec. Let's talk about proteomics, metabolomics using. Oh, my camera shifted. Look at that. Oh, that's fun. You guys can see the signature board right there. So every single guest that comes on stream, they sign that board that you can see in the corner right there. So yeah, it's getting pretty full. It's kind of fun. So yeah, Chad got to sign the board earlier today.
This is pretty wild. I'm like absolutely.
Lori, welcome to the stream. Thank you for joining us. Staying warm, hopefully. Not in Tallahassee until tomorrow. But yeah, tonight we are drinking. We started with High Lie, one of Eugene's favorites, actually. So Cigar City. And then we moved to Sierra Nevada Pale Ale. So Chad listed 2 beers, and coincidentally, I had both of those beers in my fridge, actually.
Well, there you go. We've
So,
got similar
it worked
tastes.
So that's one of the things I love about this. Oh, look at that.
Did it?
One barricade down. Let's do this.
Yeah, we'll see about that, right? Oh yes. Oh, this is extreme. Extreme.
But the nice part about Nintendo is it's always the same, right?
That's
it's
true,
the
yeah.
Same pattern. You just got to get used to pushing the buttons at the right time, and then you're good. But yeah, Lori, we're about 3 drinks in. It's fine. We're staying warm in cold weather. Usually I have an air conditioner on in this room, but I don't need to right now because it's, 26 degrees out?
No. I don't think I'm gonna make it past. I have to be honest. My ability.
29 degrees out right now.
That's cold for Tallahassee.
Yeah, exactly. All right, we should do another.
No.
We should do another one. How about the crude oil question? That's kind of a fun one.
Sure. I like it.
All right, we're going to put up another prediction. If you're not following us, click the follow button. 1, we like numbers. 2, you like internet points that you can spend on these predictions. Click the predict button. You're going to give a question. What are the number of species in crude oil? So you take crude oil, take a chunk of crude oil, take it out of the ground, a volume of crude oil out of the ground, and you put it in a mass spec, a high-res mass spec, an FT ICR. How many species can you see? Greater than 1,000, less than 1,000. And so like you have methane, ethane, propane, you have octane, you have these long chain oil products, you have gasoline. There's a whole lot of stuff in there, but is the total amount of species greater than 1,000 or less than 1,000? Contra. I don't think I ever managed to pass this level.
I don't think I did. I mean, I don't know if
Do you have to press jump or what? I don't.
you have
remember.
to hit
You have
jump
forward.
you have to hit jump at precisely the right time when you hit this. Oh, I missed
Or is it like speeding forward? I don't remember what the.
I think you have to hit jump right as the jump goes underneath your speeder. So it's, and I missed it there. Like it gives you a boosted jump if you hit it just right.
This is like level 2 of the stupid game. Because there's the one speeder
There,
bike
see,
level.
I got it.
There's a speeder bike level. There's also a. There's also. Do you remember like the geometric walls you have to climb with the unicycle thing?
I've never made it to that level, so I would not know.
Man, there's so many unforgiving levels in this game. Absolutely devastating. All right, put your predictions in now. You guys have about 30 seconds to answer. How many species are present in crude oil? Is it greater than 1,000 or less than 1,000? Yeah, crude oil is an interesting mixture of things.
It sure is. I mean, it's like basically decomposing dinosaurs.
This question of how many things does it decompose into? Less than 1,000, greater than 1,000? Put your predictions in now. The handheld unicycle, yes. And you have to like ride the walls, and you have to press the arrows at the appropriate time to ride the walls.
Oh. I think I'm gonna have to cash out on this guy.
This is it. We still have more. We got Double Dragon. We can also do Simpsons Arcade. So
All right.
it's up to you. You got about a half hour. I'm gonna guess you're about 20 minutes on NARC. So at 10:40 we'll bail on this and we'll switch to NARC. So whatever you want to play before that.
I can keep trying if people are, this. I'm getting a kick out of it, but oh, come on.
Unicycle. Yes, that was the first Battletoads game. All right, Chad, what's the answer? How many things in crude oil?
Much greater than 1,000.
Much greater than 1,000. What's the current consensus?
We've seen in upwards of 200,000 to 300,000 different chemical species and certain types of crude oil.
Man, that's crazy.
Yeah.
I mean, so that's
Yes.
taking. Oh, nice jump.
Oh.
Get it?
Oh.
Oh, what?
How did I miss that?
Super Callahan, I enjoy watching you try. Cuddle puppy, dying is his fetish.
Yes, that is true.
Someone. Oh man! All right, greater than 10,000. You said what was it? What's the current?
I mean, we have
resolve.
We have world record spectra that are in the upwards of 200,000 to 300,000 unique chemical species.
That's crazy. Anyone not familiar with the process? You take 500 million year old algae and you put it underground and you put pressure, temperature, and time, and it just decomposes into a whole lot of shit. Like hydrocarbons, nitrogen containing, oxygen containing. You mix and match atoms together and you get tens of thousands of different molecules that exist in it. And so when we take oil out of the ground, we do this, multiple processes, distilling plus cracking. Like gasoline is not the primary product of crude oil. That's one of the products. But yeah, it's a process to separate that and purify it. Yeah. One of the fun things I learned from my former colleague, Alan Marshall, who's now an emeritus professor, is that apparently with oil spills, if you sample the oil, you get a fingerprint signature for a particular oil company or a particular well.
That's right.
Which is kind of crazy. So how does that work? It's just the species present or the amount of those species?
Yeah, it's the species present, it's the amount of them, and it's because in a mass spec we're working in under the auspices that our technology is linear, where the amount is proportional, the signal magnitude that we see is proportional to the amount that's in the sample, provided we've undergone appropriate controls, right? But so the peaks we see, their positions in both X and Y, determine are essentially the essence of that fingerprint.
That was a good job.
I know, that was...
I love how devastating the collision is.
I know. It's like
the
it reminds me,
and the visual is just holy shit.
It's not quite the Dark Souls you die.
No, but it's a gentle version of that, which is almost more insulting. Like you're taking it from.
Yeah, I'm taking one for the team.
And the sound effect is just, oh my god, that's pretty brutal.
All right, let's. I feel like I've had my fair share of Battletoads.
That's enough. You drew the line. Oh, that's a shame because we just got rated by Actual Education. Actual Education rating with a party of 12. Welcome to the stream. We got Chad Weisbrod. He's playing a little bit of Battletoads while talking about mass spec and measuring mixtures of things and proteomics and all sorts of stuff. But also while playing a little bit of Battletoads and getting destroyed by the speeder bike. If anyone has advice or suggestions how to beat this, feel free to throw this in chat. But yeah, you guys should check out Actual Education. We love educational streamers. Actual Education, if I remember correctly, does a whole bunch of I think it's math and science tutoring and things like that, but actually interacts with people on stream. Let me find office hours on stream, which is kind of fun strategy. So yeah,
that's awesome.
Check it out. Actual Education. Did you call GameStop and ask them if they have Battletoads? Are you familiar with this meme?
No,
This is a 4chan.
You know what?
A decade ago.
Okay. Maybe I am familiar with that. Like, for collectors, you mean like they're trying to get their hands on a copy? And
no, this was like 4chan, the be like anonymous, just fucking with GameStop and whatnot.
Oh, okay.
For Battletoads.
No, I'm not familiar with that,
but yeah, that was one of the classic memes on 4chan was call up a GameStop and ask if they have Battletoads.
I feel like this is truly showing just how poorly my Twitch response has aged with time. I cannot.
You can't. Your fast Twitch muscles are gone.
They're gone.
We can switch up the game, but what do you want to switch to next?
Why don't we try Double Dragon?
Double Dragon. All right. That's
Double Dragon 2 or the original?
This is the original. You want to?
I think I would prefer 2.
Let me find 2 for you.
Or we can play this. It don't matter.
Well, you get started on this while I search for the other one.
Sure.
Double Dragon. NES, yep, original controller. Not stream files. I will find.
They stole my girlfriend.
What I love is the storyline and lore of the original is just.
They stole my girlfriend.
Let's try it.
First they hit her and then they.
You got 3 cheats active. Let's see what those cheats are.
No falling. No low energy?
Not from water, so you're basically invincible.
Awesome. This is exactly what I need.
Redemption arc. We went from Mega Man X to Battletoads to we can't die.
Yeah. Let's see. I know, like, I forget. There's like, can't you do like a super knee or? Oh, there we go.
Contra. I would call GameStop and ask for combat amphibians or fighting frogs. That's amazing. Battletoads be damned. All right, Double Dragon 2, ladies and gentlemen. If you guys have questions for Chad, he's happy to answer them, talking about, basically using ionization plus magnetic and electric fields to figure out compositions of things, whether it's crude oil or proteins in composition. Just trying to measure stuff really, really accurately and doing so under high magnetic fields. In fact, his field is something like 21 Tesla and high vacuum, which we decided was... 8 orders of magnitude more than a Dyson?
I think at least.
And magnetic fields, probably...
That's a 3 beers estimate, by the way.
Yeah, that's fine. Someone double check the math and challenge us. But yeah, let's do it. Let's play some Double Dragon 2. So how long has it been on this one?
It's been a long time. I'm getting a little concerned that I'm hitting women in this game. I don't know how people feel about that, but that's not okay in real life.
I mean, no, but this is gender neutral violence because you're hitting both men and women.
Oh, okay.
So I'd argue you're progressive to some degree.
Okay.
Like they're not just the girlfriend or the sidekick or side whatever. They're actually involved in the gang warfare.
Okay. So they're Well, they're attacking, right? So you got to defend it.
Yeah, exactly. It would be sexist not to hit them.
All I'm saying is like.
All right, I'm gonna run to the bathroom, but before I do, I want to ask you a question. Oh, this is a fun one. What's your airplane conversation like? You're flying from Tallahassee to Atlanta, and Atlanta to somebody else, and they ask what you do and where you work, and you're like, I work at the Mag Lab. What's that conversation look like?
That's a really good question. And I would say that a lot of times people are surprised. I don't think it's often folks sit next to a scientist and of course, once you put a quarter in a scientist, they'll keep talking forever. But typically people are pretty surprised by my profession and doing what I do. It's something that's pretty outside the ordinary, and they're usually pretty interested in that. There's a lot of follow-up questions, I would say. Man, these guys with the pipes. After Ken's done using the restroom, I gotta say it's gonna be my turn, because not only is my Twitch response reduced, I feel like my bladder volume is also not as good as it used to be. So I'm gonna need to take a break here pretty quick too. But I'm proud of myself that I made it this at least I made it to the boss. That was a speed run. I'm impressed.
Sorry, I missed the answer. What's your short summary of that answer?
My short summary is people are always very surprised, and they usually have a ton of follow-up questions.
Oh, that's fun.
It's usually a segue to a lot more discussion than I typically would like on a plane. Usually, I just like to.
Man,
honestly, this is a great segue to talk about handhelds, because like one of the things that I like to do on a plane is play handheld video games.
Like Switch, or what's your go-to?
The Vita, the Switch. I've got this new cheap Chinese handheld, this Anbernic thing that plays all the way up to PS1.
Oh, nice. So you're going to be playing a whole bunch of Mega Man X in the near future?
You know what? Given the quality of my Twitch response, I pretty much am relegated to RPGs at this point. Like turn-based RPGs.
That's fair.
Yeah, so...
I don't know. You seem to be doing well in this one.
This one like is well trodden territory for me. I used to even play this game with my dad back in the day. Like I got him to play this game. He liked it.
Have you seen this wonky new handheld capped playdate?
Ooh, no.
What is that?
Oh, is that the one with the fishing? Like it's almost like a reel on it, like a fishing reel on it. Is that what you're talking about? And they release games, like the games come from the developer. I have heard of that thing, and I kind of want it. I like that thing.
This thing, it looks like a game.
Yes, it has a little, on the side of it, there's actually a little like crank. It's like a fishing reel. Yeah, it's pretty cool.
Look at that.
It's got, that thing captivates my interest, but the developer automatically loads new games like at some set interval, like once a month. And you don't pay for games. You just like, it's weird.
Huh.
Yeah.
So it's not a subscription-based model. It's just
you buy the device. Yeah, the device is kind of pricey though, right? I mean,
I don't know. There's a link if anyone's interested.
I don't know. This cheap Chinese console that I have,
it's $200 for it.
I have a 406H and this Anbernic thing, and it's like $50, and it's pretty impressive for the price. It's wild, I think.
Yeah, see, the secret is you got to get on the airplane and tell them that you're a chemist. And they'll be like, I hate that class, and then the conversation's done.
Then the conversation's over.
That's at least my...
Organic chemistry is a significant weed-out course. So I should say that like I started my life as a chemist, as a physical chemist. I was in someone's lab who was doing Raman spectroscopy on dye-sensitized solar cells. So I feel like there's got to be some overlap between what you do and what I was.
Oh no, absolutely. We do Raman on our surface surface bound stuff all the time.
So we were doing like on beet juice, we were looking at using like ruthenium compounds in beet juice to as an electron, you know, carrier for the process of photo capture and electron transport. But yeah. Oh man, these guys.
It's kind of tragic because I'd basically given up on dye sensitized solar cells.
Really?
Yeah, so they came into play, it was 1991 was when they first came into play. And then for 10 years, you get to be a promising material. And then when you don't materialize into something that's available, it's
that's
like,
right.
What do you do with it, right?
Yeah, I can see that.
Then perovskites came along and completely destroyed everything. So, yeah, you know. But they're still near dear to my heart. Like, we do surface-bound molecules, but we apply it to other stuff now. So,
see, I love physical chemistry, and I was like, I actually, you know, and my master's is essentially physical chemistry because I went through the full physical chemistry course series and passed the physical chemistry qualifying exam. But I ended up realizing that analytical chemistry was a more fruitful endeavor in terms of being able to you know, pay the bills and support a family.
I mean, but looking at what you do now, I mean, what's the boundary between engineering and chemistry?
Oh yeah, so like what I do now, it's a pretty I mean, it's basically like a pretty awesome mixture of physics and chemistry, and so that's where I really shine in terms of being able to I groove on that sort of stuff.
But do you also like program? You build like
I build the hardware. I program the mass spec. Like on this recent upgrade, I've written thousands of lines of code to drive the mass spec. I write it in Lua. Like a lot of it's in C#, a lot of it's in Lua, which is also a programming language for video gaming. So yeah, it's good stuff.
Everything.
Yeah.
What's your favorite part of it? I mean, ignoring previous discipline, what do you enjoy most on a day-to-day basis?
You know, I really enjoy if I come up with a unique idea and I test that idea and it actually works. That's like the most enjoyable thing about science. Is like taking an idea from like basically it's birthing that idea and taking it all the way to the finish line. There can be nothing more glorious than that.
That's awesome.
When it happens the way you think it should, which is not often, right? So it's this
serves as the perfect segue to my next question. One I like to ask every single guest is that, you know, you scrounge for money from the NSF to try to make incremental progress in what you're doing. If you had unlimited budget and no moral qualms, what would you do? What would be your holy grail? We're talking 100 Tesla, like.
Yeah, I mean.
That in?
Okay, yeah. So my holy grail would be this. This is like I would want to reduce the pressure in the measurement to the point where there are basically no neutral molecules, because in that case, if we're at a point where we've studied this instrument so carefully and developed the hardware so carefully that our limiting problem is collisions with neutrals. So if we could get the vacuum down even lower than it is, we could measure ions indefinitely and increase our resolving power and everything that way. We actually have to do that before we go to higher field, because going to higher field increases the kinetic energy. And so, you know, right now, let's say at 200 m/z, we're at 50 keV of these orbiting ions. That's their energy equivalent. If we increase the field, if we double the field, we're going to be doubling the kinetic energy. And so collisions become, we talk about mean free path. What's the minimum distance before an ion is going to make a collision with a neutral? So that's our fundamental performance limiter. So that's what I would do. I'd spend the money on doing that. And that's what we are doing, but I would more actively pursue that, like much more actively.
I mean, so that's crazy that you guys are limited by vacuum. I would not have expected that.
Yeah, it's pretty wild. Yeah.
But like, so what's the highest commercial vacuum that you can buy? So you're 10 to the minus 11.
So you can't really buy, you can buy vacuum pumps, you can buy cryo pumps. There's different types of pumping technologies out there. The traditional, like the technology that wins the day right now is what's called a turbomolecular pump, which is essentially a turbine that spins really fast. It's similar to the jet engine that's on an airplane, only all it does is spin and pull molecules. It compresses gas, and then on the other side of it, you've got a rotary vane pump, just a standard, almost like a vacuum cleaner, suck in the gas that's been compressed on the other side of that turbine. Those things have their limitations. They spin only so fast, so certain gases like helium and hydrogen, they're not pumped efficiently because they're at ambient. Their compression ratio at the speed of the rotary pump is not sufficient to pump them away. You know, so the compression ratio is what determines how. Oh man, is it Bobo or a Bobo? This guy's kicking my butt. Why do they gotta put spikes on the ceiling?
So is that a technology limitation right now, or is that
it's a technology
for vacuum?
Oh, it's a technology limitation. So well, like you could we could design
with technology, you could get,
we can push the limits, like
10 to the minus what?
Well, also for a mass spec, we still have to have an orifice to let the ions in, right? So that's what limits us. And we have like this differential pumping, so we have stages of vacuum. The first, so we go down, and we've got like 5 or 6 stages of pumping to get us to 10 to the minus 11. So
with current technology, assuming you don't innovate in the vacuum world, what could you get to?
We're basically at our limit.
You are? Okay.
Yeah,
so more money's not solving this problem. You need innovation.
And there are alternative technologies, like cryo pumping is another technology where you simply cool the surfaces off in the instrument, and in that way you condense all the neutral molecules that are giving you this grief.
Interesting.
Yeah.
A properly vacuous ambition.
Exactly. Yeah, he's been on the stream for a bit, huh? I've got to take a break briefly. Use the restroom.
I'll keep playing for you. We're making progress. Sorry, it's been so long since I played Double Dragon. I'm gonna all in. Properly vacuous ambition. Oh, there's a ladder there. Look at that. I just lost a life doing that. Jump was the double hit. We do a bet on Chris's or Chad's NARC time. So like our range of NARC times for the entirety of the stream has been between 26 minutes, between 16 minutes and between 38 minutes. Oh my god. No one can tell where these borders are. What's your guys' guess on Chad's time on NARC? Notice he's been playing like 2D platformers the entire time. I gotta imagine he's gonna be okay at these. $10 hours. Lori's got to guess at 22 minutes. But that is one of our predictions. I should probably throw up another prediction. 30 minutes? I don't know. I think it's going to do well. I'm going to guess under 20 minutes. Like, it's not that different than the Double Dragon. The rate limiting step is always the jump rocket on Mr. Big, so... You can do Mega Man, I want to believe. Oh, right. Alright, there we go. Oh god, another one. You could start the first outer space bottled vacuum company, Easy Refills. What is space vacuum? Astro, maybe you know. So we were talking about 10 to the minus 11 torr for like the system that they use. The vacuum that they pull is 10 to the minus 11 torr, which is ridiculous. Like a standard pump we use for a Schlenk line is something like 10 to the minus 5 or 6. So they're doing super ultra high vacuum. I don't know what the vacuum of space is, but it's not a vacuum. There's a surprising number of atoms in the vacuum of space. Huh. Oh man.
Have you kept me in the game, Ken?
I have.
Way to go.
I got through this terrible platform.
Oh, this guy's crazy.
There you go.
So this is a pretty sweet setup. You got the bathroom is positioned just perfectly. So that you don't have to, it's like a game on, man. We're back in the game.
Pure coincidence that I hijacked this for video games.
Okay, so I forget.
It's also our guest room because that couch pulls out the mattress.
Ah, okay.
Yeah.
What do I have to
I
do
think you
here?
just have to get up here.
Get in
and
that
then
door?
Here. Yeah.
Okay, I know.
This is
I
just
guess,
straight up platforming.
which is I didn't know that was a thing.
Yeah, so we're at 10:24 right now. I'm thinking I'm gonna guess 20 minutes for your arm. So maybe at 10:35 we switch.
Whoa,
to
you're
that.
giving me like a I don't know.
I have to balance our 11 o'clock's end time.
Yeah.
With what I think your game is going to be.
That's right. Okay.
All right. AI says that we were talking about vacuums and the varying degrees of vacuum.
Yeah.
AI says the vacuum of space is considered to be extremely high vacuum, with a pressure so low it's nearly impossible to measure accurately. But generally it falls within the range of 10 to the minus 6 to less than 10 to the minus 17 torr.
Yeah. So like physicists, actually when you get beyond 10 to the minus 11, it actually gets hard to measure. So there's these gauges, they're like, you have hot cathode gauges or you have cold cathode gauges. But these gauges essentially, you're boiling electrons off the surface by passing current through like a filament, and you're collecting that electron current. And the disruption of that current collection is proportional to the pressure. Essentially, that's the basic principle. Mm-hmm. But that process actually it doesn't work as the linear dynamic range for that process isn't valid as you go to lower and lower pressure. So we're at the point where we have to start using molecules we have to try to measure their collisions in the spectra to tell us what the true pressure is. Because we've essentially bottomed out the gauge. Huh. Yeah, it's pretty crazy.
I mean, so 10 to the minus 6, misadventures in Astra is confirmed. Minus 6 is like low Earth orbit, so it presumably gets much higher than that. 10 to the minus 17. Have you thought about building a mass spec in space?
Oh, people have definitely thought, like on almost every exploratory, like these landers and stuff, they typically include some type of mass spectrometer on them, which is really fun. Like they've never incorporated an FTMS analyzer to date yet. They've typically incorporated time of flight analyzers or ion trap or quadrupole based analyzers. So
I mean, presumably the limitation there is cooling, right? Like you have to be able to cool the magnets, which is an extra cost, right?
Yeah, so I think a magnetic, like an ICR in space is probably a non-starter, but there are these electrodynamic ion traps. They're called, like an Orbitrap would be, or there's higher order, there's traps that you can make that aren't commercially available. They're generalized to what's called a Cassinian trap. So, and I don't know, this is really specific information, but you can trap ions in just an electrostatic field, and you don't need a magnetic field. But there is a Russian colleague of mine who's been trying to send one of his electrostatic ion traps on a Russian satellite for a while now, but
Yeah.
I haven't heard from it in a while because of the countries of concern law. So
Yeah. So it goes.
Yeah, so it
We won't
goes.
even dive into that one.
Yeah.
That's a pain in the ass, but man. So it doesn't really help us doing this in space unless we can cool the superconductor and actually do the measurement.
That's right. And somehow I was able to pass that gauntlet.
You're doing great. You got about 5 more minutes before I'm going to transition us to NARC.
NARC. Okay.
Are you ready for this?
I don't know, but like I remember playing NARC way back in the day.
Did you play it on the arcade or the Nintendo version?
I played the Nintendo version.
Oh wow, you are one of the few. I don't think I've ever had a guest that actually played it.
Yeah. So, and I mean, I played a lot of what is it, like Akari Warriors? Like I was into a lot of those kinds of. Metal Gear was also one that I was a fan of.
No, I'm impressed. So this one, like us playing NARC every time, started out as a joke. And it was like it was one that I had as a kid because it was a bargain bin game. Right? I remember when you could win out of like Blockbuster and there was like $5 games.
Yep.
NARC was one of those shitty games, like because it was an arcade like you'd find in Pizza Hut, and then they put it in NES, and they like it's not as good as that.
It's not even close.
But like. It was something that I played when I was young, and then I played it when I was a guest on the stream, and then I forced every single guest after me to play it. And so it became a challenge to challenge each other.
I'm going to be honest, I forgot about these platforming elements in Double Dragon 2 that are...
Like, you got to jump before the platform is there.
Oh!
It's so annoying.
It's brutal. I like how it made me fall and look like a...
Ooh. Lori has an important question. So you've played NARC, but have you won the war on drugs? Did you beat NARC back in the day?
There's no way.
Oh, that was good.
Yeah, it was close. I have not won the war on drugs.
Contra. Sadly, that war has had only losers, yes, in reality. But in the NARC universe of NES, it has winners. And they are you if you beat it.
Oh. Too soon. I hope I win.
You will beat it. It's just a question of how long it takes you.
If only the war on drugs were that simple. All you got to do is beat Mr. Big, right?
Tonight it is. That is it. You just got to kill Mr. Big, walk off with his gold.
And then everybody wins.
Everyone's happy.
Yeah.
Oh, man. We should do another prediction quick. Which one do you want to do? Some of these we've answered already.
Yeah, we have. How about what was the original purpose of a cyclotron? That one's kind of fun.
Do that. All right, we're going to do another prediction quick before we dive into the world of NARC and win the war on drugs. Maybe. We'll see how it unfolds tonight. But we are.
It might happen. It might not.
Every single guest has beaten NARC, whether it's with or without my assistance. We will win the war on drugs tonight. It's a question of how long it takes. But before then, we're going to throw up a prediction right now. Click the predict button. What was the original purpose of a cyclotron? Like, why did people do cyclotrons? These are particle accelerators. Why did people do it? Was it, or why did they make cyclotrons? Was it strictly for particle acceleration, or was it for mass spectrometry? What was the original goal associated with it? The war has had only losers, except for us, because we get the game NARC because of the war on drugs. All right, anything you want to add to this question? What was the original purpose of a cyclotron? Do you want to say quickly what a cyclotron is? How about that?
Well, I think if I say what a cyclotron is, it might give away the answer, but I will just say that Ernest O. Lawrence developed a cyclotron in 1939, and he won the Nobel Prize for it.
Oh, that's interesting. How soon after development did he get the Nobel?
I don't know. I don't.
This is the worst timing because you're like jumping early.
Yeah.
Like, I don't want to fall straight down. I want to.
But also, it's the worst timing because I'm like 2.5 beers in.
Yeah, that's it. This is a non-trivial jump.
It is.
I can't remember the last guest that played this, but I think I beat this section for them because it was
tough.
Yeah, no, this is one of the hardest parts of the, especially even in Infinite Lives. You don't get any advantage here.
No,
you have to grind it.
This is like a, this shows your gaming street cred right here. If you can pass this sequence, you're.
No, the impatience.
Yeah.
What was the original purpose of the cyclotron? You guys have about 10 seconds left to answer this question. And you gotta wait. Cycle to get the game back.
It's like, and it's painful too to wait.
Injury.
Oh,
Such a small window. You guys should play some Double Dragon 2 because this is nightmare fuel.
Here's my question. One thing I can't remember about Double Dragon 2 is like, if you're playing 2-player, do both players have to make it in the door, or just one player good enough? You know what I mean?
Oh, I do not remember. Oh, that is an excellent question.
Yeah.
I want to say only one, but I could be wrong. Any Double Dragon 2 aficionados in the chat that knows the answer to that question? All right, Chad, what's the answer? What's the original
Particle
purpose?
acceleration.
All right, so let's start with what a cyclotron is. So you said you'd give away the answer.
Right. So it's a large magnet that is circular in nature, that accelerates ions in a circular shape. So in a big circle, but they have better means of particle acceleration at this point in time. So they don't use cyclotrons.
Wait, what's the cutting edge?
Oh, I mean, like CERN, you know, like these, they can't, the reason why they don't use cyclotrons anymore is because they can't produce ion energies at the levels that they need for the kinds of collisions and fundamental physics that they want to do anymore. So they use, you know, CERN as one of these cutting edge, know exactly how that facility operates, but
Oh. Coming up on 10:35, I'm going to start to get NARC set up. Do you want to see the timer or don't see the timer?
you can leave the timer. That's fine.
You want to see it? It's okay if it's
Yeah, it's okay if it sits there. It
No,
won't.
you're okay with the pressure?
Yeah. Performance-related anxiety. I think that everybody has already seen my gaming abilities here. They know what I'm capable of at this point.
All right, we'll put a clock up in the corner for the audience to watch it. Give you a few more tries, and you'll have to let me know when you want to jump to NARC.
Okay.
If you jump the instant you see the flash, it'll work.
You think so?
That is the device from Contra.
All right. I'll try it. No, I did it too soon. No, I
Too
didn't.
early. It was good. I think the strat is good. I think that's good.
It
advice.
helped.
Contra,
It helped.
Thank you. It's just got to be patient.
It helped.
Right?
It helped big time.
Wait for it.
This is probably going to be my last shot.
All right, so particle acceleration was the original goal. So this brings me to a question I've been meaning to ask you. So you talked a lot about neutral... Oh, no, there it is. You talked a lot about neutral molecules just floating around in space being a problem, but why do they go in the cyclic... Why do they go in the cycle if they're neutral, right?
So they're just bouncing around inside there randomly, as you might expect from your chemistry or your physics and chemistry background, but they still have a probability of colliding with an ion that's moving in the circular pattern.
I see. It's not the cycle. It's because it's closed chain.
Yeah,
It just bounces off the walls.
Based on the number density of the gas, you have some probability of collision with the ion. So
yeah, that was just, I mean, something I learned about.
so you can back out the pressure and the number density of the gas simply from.
Take your time.
Oh, I didn't die. But that really doesn't matter.
It doesn't. There you did. Well, it was one of the things that blew my mind when I learned about Oak Ridge, and I was visiting. It was actually an RU program as an undergrad where I got to visit Oak Ridge, and it was like, I never thought of it before, but they don't accelerate neutral things, right? Because you can't. It has to be charged for a field to matter, an electric or magnetic
That's
field
right.
to matter.
Yeah.
And so the neutral things, like neutron scattering, is a very common thing, but it's not neutrons that are being accelerated. You accelerate things that are charged into something that generates neutrons.
That is correct.
And that's how you do it.
And then you just have an aperture that that directs the neutrons. You can't steer a neutral species.
Which is crazy because they presumably have isotropic generation, neutrons shooting every direction, and they're just like, go through this hole and you're useful in this hole.
That's right.
And that kind of blew my mind because I'd never thought about it before, but it makes straightforward sense.
Makes sense, doesn't it?
Oh, over jumped it. That's brutal. That is very Buddhist of the particles. Yes. If we want to personify particles, that's amazing. All right, Lori has requested a factoid, so let's do that. I'm going to put NARC on the screen. You can knowledge bomb before we start some NARC.
So the amount of wire to wrap around the superconducting magnet that we have in our biggest magnet is 350 kilometers of superconducting magnetic wire.
Holy shit. So that magnet is what, like 2 feet wide, something like that?
Oh, like the actual the cryostat, we call it a cryostat, where the magnet lives. It's almost 2 stories tall. So
holy shit.
It's pretty big.
How big is the actual magnetic coil? Diameter wise.
I don't know exactly, but I want to say it's certainly not as big as that. It's probably about a meter.
About a meter.
Yeah.
Okay.
The bore of the magnet is about 4.5 inches. So it's pretty small. Like the hole that goes in where we put the instrument.
But the length you said, how long was that?
350 kilometers of superconducting wire.
That is intense. You've got to make a uniform wire and coil it around. Oh, before we go, we're going to restart. Sorry. Okay. I got to read you the lore so you know what's going on.
The lore.
Yep, you need to know the backs. Here's the...
Oh, you have the
original cartridge.
You have a... Wow.
NARC. No one had the guts until now, because you need to know what you're playing. This is important. You are Max Force. Your mission: bust Mr. Big and destroy his dreaded criminal empire. Seize all contraband, stolen money, illegal weapons. Use rocket bombs, high-powered machine guns. Apprehend all suspects. Protect the innocent. Punish the guilty. Stop at nothing.
Was this game funded by the Nixon administration or what?
I always like to make the joke it's written and directed by Nancy Reagan.
Oh, okay.
No, as far as we know, it's not. All right, you're up. I'll start the timer as soon as you hit the ground. Your goal is to walk right as fast as you can. No advantage in killing people except at specific people, but yeah.
Okay, so it's just ignore all the junkies.
Exactly. Misadventures, I know where I'm stealing my copper from.
I feel like you're going to give me pointers so I can...
Oh, no, you just walk right. I'll tell you when you have to shoot
Does he walk
people.
Does he walk faster
no,
when
this is the only sauntering pace you get.
Okay. But if I'm shooting the gun, does that slow me down?
It does not. Walking up and down does, but walking right left is good. So yeah, you want to
just talking about efficiency here.
No, exactly. No, you're doing this right. You understand speedrun scripts. Bullets slow you down, so you can jump over those if you want. But yeah, there's not a whole lot of copper because the wire is super thin, right? It's pretty
thin.
Not like you're thinking about electrical housing wire. It's got to be 100 times thinner than that, right?
You know what? I don't have a great number for you on how thick the wire is.
Card slot. There you go. Then through the door.
The card slot. I needed the card slot.
Yeah, it's realistic.
Yeah.
One way to find out.
the quack stop
selling copper.
Positive.
Oh yeah, on the arcade it was called the crack stop. For Nintendo, they whitewashed it and they're like, the quack stop. This isn't drugs. This is quack.
Quack. Everybody's smoking quack.
Yeah, and those aren't heroin needles. I'm sure they're fluffy bunny needles. I don't know.
Yeah. Oh.
Yeah,
that's not good. Oh, those are like heroin. Tranquilizer darts. Oh, they're
heroin needles. You remember the 80s? You did Dare, right?
Yeah. So, does that mean now that I've been shot with a heroin needle that I'm addicted to opiates? Is that the...
No, it just slows you down through the door. All right, here's going to be your first one where you have to actually shoot someone to get a card off them, and I'll tell you how to do it when you get there. But if you guys have questions for Chad, I want to distract him from his time, because he is taking this seriously as far as I can tell. So.
As seriously as you can for a speedrunner.
You're going to have to shoot the guys wearing black with bullets at relatively close range, and one of them is going to drop a blue card. So you want to let them walk closer. You can shoot the dog by pushing.
Why do I have to shoot them at close range? That's kind of weird.
There's the card. There you go. All right, that's a good drop. You're good.
There's something there. Like
Misadventures is redeemed. Take a drink. So cheers. While we
cheers.
Go through the levels.
Yeah.
Thank you, Misadventures. Thank you as always for joining us. So we win the war on drugs, but also talking about mass spec and measuring things, magnetic fields,
we're getting
high vacuums. 10 to the 17th, 10 to the minus 17. What would that do for you? Oh my God, Laurie redeemed another one. Drink and drive. NARC, drink and drive. So you're going to get up on a car here, and I'll tell you when.
Get up on a car?
Yeah, you're going to ride a car here, and then you're going to crash into a wall, which is why we NARC, drink, and drive. Sorry, 10 to the minus 17. What could you do with that? How much would that help you?
It would help us tremendously. So that would, because, proteins get large, like we could make better intact mass measurements.
All right, press B to jump. And you
All
can
right,
stay on the bottom.
Whoa, this is,
And then there's a wall. So yeah, you don't get much out of that one. Next card you'll
that's
get more.
too bad. That was
It was fun for a moment.
short-lived.
All right, sorry, 10 to the 17. So that would help you with resolution. That would help you.
And all the above. It would also allow us to make intact mass measurements better for large species like proteins and very large biomolecules. So, certainly human proteins can range in size from low kilodalton to what am I going to
Jump over this. Those are dumpsters, believe it or not.
stacked up on the roadway?
Yep.
Filled with drugs, probably.
Free drugs. It was the 80s. It was a different time.
It's a different
Kids these days. You have Skibbity Toilet. We had drugs everywhere.
Yeah, so so I'm not sure, how old are you, Ken? Or is that
I was 1982, so I'm 42.
I'm 1982 as well. So
Okay.
do you consider yourself a millennial, or do you consider yourself a member of
So
Generation
according
X?
to every generational divide, we are the eldest of the millennials, right?
Right,
In terms
but-
of life experience,
Okay.
we're zennials, right?
I was going to say, like, if you grew up in the Midwest, which it sounds like you did in Minnesota, I would argue that we are Generation X simply because...
The 5-year lag.
Exactly.
Yeah,
That's
yeah.
right. Like, you have to apply a correction factor.
You do. I mean, but the thing that we share with millennials is the onset of the internet.
That's
we
true.
experienced
That's true.
that. So I think we get both the lenses, but I don't know. Who would you would identify more with? Gen X?
I don't know. Probably, I think probably, I guess at this point I would say it makes sense to use the term you used, is that we're seeing it from both lenses.
Yeah. Which I'm happy with. Like,
Yeah,
okay, so
sure.
you're going to get in the car, stay on the bottom.
Oop, dude. Thought I was
Tap it gentle.
Normally you
Go.
just jump in.
Stay on
That's
the
how.
bottom, go up,
Okay.
go right fast. You're going to run into a wall, but that's fine.
Is it fine?
Unless you memorize this path, it's really hard. to
Yeah,
find
there's
that.
no way.
But yeah, I definitely feel the zennial. I feel like we got the heyday of the internet, like the wild
Absolutely.
west of the internet.
Oh yeah,
Zero
and
regrets on
Napster and like
LimeWire and,
LimeWire, yeah.
and Winamp and
It really whips the lava fast.
it really does. So, yeah, Kazaa, yes,
Yeah.
there we go.
Yeah.
Misadventures knows you feel
Or AOL. I mean, that was like
even that.
That's way old
The,
school.
the ASL chat, yes. All right, you're going to stay on the bottom on this. So get in the car, stay on the bottom. Oh, stay on the bottom. Okay, you're going to walk.
I got scared. The barrels were in my.
Yeah, no, I apologize. I should have said you can drive through the barrels. No worry, you're just going to walk to the end. You're going to saunter to the end. This will cost you some time, but we can make it up later.
Perhaps.
But yeah, I have zero regrets about the early internet. All right, what do I need to ask you that I haven't? Do you remember any of the questions that you... Oh, what is the Earth is flat or anti-vax equivalent of your field? What kind of dogmas do people bring to...
People bring a lot of, you know what? Surprisingly, people bring a lot of dogmas to mass spec. Like, it's still kind of it hasn't reached the state of maturity that, say, like genome sequencing has. Like, and so there are
Jump over. There you go. Doors at the end here.
I can feel the pressure.
No worries. You have like 10 minutes to beat this. The world record is 9 minutes and 4 seconds, so I don't think you're beating that.
No. This is by the way, I will freely admit that this is my first time playing this game. Well, second time if you count the coaching that I got from Ken earlier.
Yeah. But you played the arcade one?
Yeah, that's right. Yeah.
Yeah, it's a very different gameplay. Roll into the end like Scarface? Yeah, absolutely.
Adult books. What is this?
Oh yeah, that's pretty edgy for Nintendo. Okay, You're gonna go through this door right here. You're gonna go to the right and pick up the card. There's a door at the end you're gonna go up through, and if you keep pressing up, it'll take you out and then take you back in. You want to stop pressing up. Oh, there it is. Okay, don't do that again.
Okay.
So go up.
I feel like this is going to be a rate limiting step for me.
You're just going to loop indefinitely.
Yeah. Okay, up.
Okay, left. See the silver card? Do that. You're good. You only lost like 10 seconds. You're doing all right. Oh, man. All right. We have, 12 minutes left in the stream, plus or minus some change. If you guys have suggestions on who we should raid, I don't know who's on right now. Looks like some Astra Canuck. Looks like Science. We'll see. This is a weird time because people usually check out a
Is that supposed to be a marijuana plant?
It is. So go left. It's the only level you go left on, actually.
Their plants explode?
Some of them are rigged with explosives, because that's how things work. Shark, that's fun. I haven't seen that one before. Let's see what Shark's up to. The marbles on stream. Seems legit.
All right, here we
They're
go.
a scuba diver and a shark nerd.
Nice.
They're about protecting oceans, especially sharks. That's fun.
That's cool.
We got a shark-related stream.
So one of my greatest passions in life, other than video games, is fishing, and I often catch a lot. I fish in the Gulf a lot.
Oh, that's fun.
Yeah, I catch a lot of sharks as bycatch. So, the big like
you own a boat or you rent a boat?
I own a boat. Yeah.
Oh wow.
Yeah. So
you transport it out, or you have?
I've got a pickup truck and I take it out.
Wow, that's cool.
Yeah. So, the biggest I caught an 8-foot hammerhead shark before. Caught some decent 7-foot lemon sharks. Nothing much bigger than 8 feet, but that's still a very large shark to catch. I don't go targeting sharks or anything like that.
Yeah, but it's just
bycatch for. Yeah.
All right, you're going to get to a key card at the end of this. You have the key card already, so just put it in the slot.
Just get her done.
Yep. Keep going.
Keep her moving.
All right. Man, were there any questions you were excited about that I didn't ask? So I haven't been keeping track of what
I haven't kept track of which questions you've asked and which one. Like I sort of briefly went through them, but I can't recall any. At this point in the night, I can't recall.
Man,
honest.
Here's a fun one.
Okay, go ahead.
You're hosting Ask a Scientist Gaming. You could interview anyone alive or dead. Who would it be?
Oh wow, that's a really I think I would pick. I think I would pick Richard Evans Schultes. That's who I would pick.
I regret to say I don't know who that is.
Richard Evans Schultes is a legendary Harvard professor who he was essentially in charge of this botany program at Harvard, head of the Harvard herbarium, and he once got a grant to go to the Amazon rainforest for a semester, and he disappeared for 12 years in the Amazon rainforest. Category, he lived with this is during before and during World War II, and it's just it's an amazing story. There's a book called One River that categorizes his journey. One of his students, his graduate students, cataloged his exploits. It's amazing. Absolutely.
He was, sorry, you're going to get to a boss. So you're going to want to blow up those dogs, shoot a rocket.
Okay. They seem nice,
Yeah, there you go. So there's a guy in a wheelchair that's going to appear, and you have to shoot him with rockets.
Oh, I like how they blow apart into pieces. That's great.
This is one of the early ultraviolet video games. So yeah, you're going to want to shoot him with a rocket.
Okay.
Tap A. There you go.
But they're just drug addicts, so it doesn't matter.
Yeah,
right?
exactly. They're not even people. Animal violence, yes.
Just dehumanize them to the point where it's okay, right?
Oh man, it is the American way as of a day ago. Anyway,
Did it?
Too soon.
What? He disappeared on me. I don't think I
He'll
hit.
come back. So you're gonna have to hit him 3 times.
Oh man, got a tall order here. What?
Oh, there you go. That's 1. So he's gonna inchworm. He'll come back, kill all the guys on screen.
He's gonna find a new wheelchair.
Yeah,
Is that
exactly. He has at least 3 of them, as far as we know.
What is he got backup wheelchairs?
Is this the Office of FSU policy on drug addiction? No.
I just want to say the disclaimer here is that none of my views.
Yeah, exactly. NARC does not coincide with the views of Ask a Scientist. But really, is this any worse than Mega Man X? I don't know. Oh, bad. Alright, kill all those guys. And you can shoot them with bullets. Yeah, there's this weird sequence where you gotta kill a bunch of them and then he'll reappear. So 1 more blue guy, then he'll reappear. Oh, there you go. Get those rockets.
No.
And then kill him again.
I appreciate your advice. I'm trying very hard.
No, it's no worries. It's not easy. This is Nintendo's hitboxes. That's 2. All right, inchworm. He's got 1 more wheelchair. Cuddle puppy. None of my views reflect my views, Dr. Chad Weisbrod.
Yeah, exactly. That's a good. None of my views. It's
Do not quote me on my quotes.
That's my lawyer, my hair lawyer speak. You can.
Your legalese is strong. Oh, there you go. All right, 1 more rocket shot.
I like it. This is
Yeah,
what
I
happens.
think you'd have to shoot a guy in a wheelchair today. I don't know if you knew that was coming, but
Well, I think I beat up some girls in Double Dragon.
there you go. All right, he's gonna dissolve into a yellow card, as one does.
Yeah, I figured that's what happened.
Pick up that card. And through the door. All right, we're on to Mr. Big, Phase 2. Here it is, ladies and gentlemen. Are you ready? This is the rate-limiting step for most of our gameplay.
This is the
So you're
pinnacle.
going to go to the top of the screen, jump, rocket him in the hat. Is your
Oh,
goal.
yeah, that's
And
right.
if you stay on the top of the screen, he can't hit you with his tongue. So tapping jump and rocket on the way down. Oh, that's it. All right, rockets to the face. Another one. There you go. Okay, walk away down here. Holy crap, that was quick. All right,
no.
Get up over here. And then bullets. You're going to turn around and shoot bullets, get some distance, turn around, shoot bullets. Holy crap, ladies and gentlemen, that was a quick hat shot.
Luck.
All right, get some
Just
distance.
pure luck.
Get some distance. Don't let him get on you or you're going to lose it. Yeah, you can get him on the other side of the screen. Fine.
Okay.
Yeah, Contra, no joke. That was quick. That might have been one of the fastest phase 1s we've seen in this.
That's pure luck.
Literally hacking.
Yeah, it's pure luck. There's no, I mean,
Keep going, keep going.
what was my statement earlier that you just quoted me on?
None of my views reflect my views.
Exactly,
All right, get
that's
back
right.
the other way. You're flying though. Let's do this. Oh man. All right. Any suggestions? I think I have. Oh yeah, shark. Let's raid some shark. Who's playing guitar while playing what? The marbles on stream. What is this game? Yeah, marbles on stream. That's fun.
Oh yeah.
Oh, there we go. 1 down.
I was gonna suggest we play some Marble Madness, but I didn't want to go
man.
insane. That game's too hard. I mean, that's
Oh, go right. Find the door. You have the key card. I shouldn't be punished for hacking just because I'm hacking. Dr. Chad Weisbrod. You're getting so many quotes tonight. This will be on YouTube forever until the internet burns to the ground.
well. I've successfully embarrassed myself
All right.
as my.
Nextly,
my
you got
daughter
1 level left.
Can I do it? Oh, it's all gold.
Yep.
Just get the gold.
Civil forfeiture level.
Civil forfeiture level. Oh no.
Yeah, so I mean, how else would you describe it? 17 minutes and 1 second. Holy crap, that was a fast Mr. Big, phase 1 at least. Wow, you crushed that. Let's see where you're sitting on this.
Is that the end or what?
Yeah, that's, I mean, it's the description. 16, 18, what do we have? 1626 is the only 16.
Third
So that
place.
puts you as third place. Yeah,
All right, man.
that's solid. That's a good NARC run. I mean, that was maybe the fastest we've had anyone beat phase 1 of that race. So congratulations. Now you got to put in your initials. This is immortalized.
Oh, wow. Yeah.
Until I turn off the
See,
emulator.
yeah, there you go. Better put it in. CRW.
Wow. Tore through that.
Thank you, sir. That was a great experience.
Wow, man. You exhausted? That was a lot of gaming to take on under lights and pressure conversation.
It was fun. Thanks for the audience's participation. I appreciate it.
All right. Well, everyone, thank you for joining us for Ask a Scientist Gaming, the first one of the new year. Chad, thank you again. Short-term notice to get all the things together, but I'm really glad you did. You braved the winter, you braved the ice and the roads. I really appreciate you saying yes and joining me. I really had a good time.
Me too. It's great, Ken.
Any parting words for the audience?
I would just say follow your dreams and continue to, continue gaming.
Oh, absolutely. And gaming and talking science. You guys are enough science nerds that we really appreciate you joining us and asking questions. It's a really good time every time we do this. So we really appreciate you helping us maintain our habit of playing video games. So next guest is going to be February 5th, Dr. Scott Evans. He's in the Earth, Ocean, and Atmospheric Sciences Department. He's a paleobiologist, and what he does is he looks at like really, really early life, like circle imprints left in the ground, and how do you differentiate those between inorganic and like biological matter and origin of life, and like how old life is on Earth. He's one of those people that looks at those organisms. So it's going to be really fun to have Scott on stream. I think he's going to play some PlayStation 2 Tony Hawk Underground.
Oh, that's great.
Yeah, we haven't had Tony Hawk on stream yet, so I'm excited to have that happen. But it's been fun. Thank you all for joining us. Stick around. We're going to raid an educational streamer, potentially Shark G33K, because that's fun. Shark aficionados are great, so we'll do a raid there. But yeah, thank you all for joining us. It's been a pleasure. We'll be back in 2 weeks. Until then, we'll see you guys later.